Today we're going to take a look at the main focus areas and features of the Oracle Database 12c. The first focus area is infrastructure grids. Infrastructure grids allow us to use low-cost servers and storage and still deliver a high quality of service in the areas of high availability, manageability, and performance. In information management, the focus is on content management, information integration, and information lifecycle management. There is now also support for advanced data types such as XML, text, spatial, multimedia, medical imaging, and semantic technology. Looking at application development, Oracle now has the capability to manage and use all major application development environments, such as PL SQL, Java, .NET, PHP, Sql Developer, and Application Express. The Oracle Cloud is an enterprise cloud for business and is based on open Java and SQL standards. It provides an integrated collection of application and platform cloud services. Looking now at the features of the Oracle Database 12c. Within manageability, the main features are database replay. This allows you to record a load on one database and replay it on another, for instance during upgrade testing. The SQL Performance Analyzer. This assesses the performance impact of any system change which could result in the change to a SQL execution plan. Automated SQL tuning. Real-time database operations monitoring. This monitors composite operations automatically. The Enterprise Manager Database Express 12c is used for managing and monitoring your 12c database. In the area of high availability, Oracle Database 12c focuses on reducing downtime and data loss, on improving online operations, and caters for faster database upgrades. The main features within the performance area are focused on secure files, compression for OLTP, online transaction processing, on rack optimizations, and in the result cache. The security features include unique server configurations, focus on data encryption and data masking, and focus on auditing. In information integration, the focus is on integrated data throughout the enterprise and focusing on advanced information lifecycle management. Lastly, the Oracle Fusion Middleware product set contains a portfolio of products that span a range of tools and services, from Java and developer tools through integrated services, business intelligence, collaboration, and content management. Oracle Fusion Middleware can enable you to maximize the processes and applications that drive your business today and to provide a foundation for innovation for the future. Enterprise Manager Cloud Control is a management tool providing monitoring and management capabilities for Oracle and non-Oracle components. It provides a complete, integrated, and business-driven cloud management solution in a single product. By using the Enterprise Manager Cloud Control, you can create and manage a complete set of cloud services, including infrastructure as a service, database as a service, and platform as a service. You can manage all phases of the cloud lifecycle. You can manage the entire cloud stack from application to disk, including engineered systems with integrated capabilities. We can monitor the health of all components, the hosts they run on, and key business processes supported by these components. We can identify and understand and resolve business problems through the unified and correlated management of user experience, business transactions, and business services across all packaged and custom applications. The Oracle Cloud is an enterprise cloud for business, providing an integrated collection of application and platform cloud services based on best-in-class products and on open Java and SQL standards. Applications and databases deployed in the cloud are portable and can easily be moved to or from a private cloud or an on-premise environment. The 5 essential characteristics are on-demand self-service. The focus is on provisioning, monitoring, and management control. Resource pooling implies the sharing and a level of abstraction between consumers and services. Rapid elasticity allows you to quickly scale up or down as needed. Measured service, the focus is on metering utilization for either internal chargeback or external billing. Broad network access allows access through a browser on any network device. The Oracle Cloud provides 3 types of services. Software as a service. This refers to applications that are delivered to end users over the Internet, for example, the Oracle CRM on-demand product. Platform as a service refers to an application development and deployment platform delivered as a service to developers, allowing them to quickly build and deploy SaaS applications to end users. Typically, you will find databases, middleware, and development tools all delivered as a service via the Internet. Infrastructure as a service refers to the hardware, server, storage, and network, and will also include the associated software such as operating systems, virtualization, and clustering. The 4 types of cloud deployment models are the private cloud, used by a single organization and is typically controlled and managed and hosted in a private data center. It can be outsourced to a third-party service provider. A public cloud, multiple organizations use a private cloud on a shared basis, which is hosted and managed by a third-party service provider. The community cloud is where a group of related organizations want to make use of a common cloud environment. The cloud is managed by the participating organizations or by a third-party service provider, and is either hosted internally or externally. Lastly, we look at the hybrid cloud. This is where a single organization wants to adopt both private and public clouds for a single application. Dr. E.F. Codd first outlined the principles of the relational model in June 1970 in a paper titled A Relational Model of Data for Large Shared Data Banks. It was in this paper that Dr. Codd proposed the relational model for database systems. Common models used at the time were hierarchical and network, and even simple flat file data structures. Soon, relational database management systems became popular, especially for their ease of use and flexibility in structure. The relational model consists of the following components: a collection of objects or relations that store data, a set of operators that can act on the relations to produce other relations, data integrity for accuracy and consistency. A database management system has the following elements. The first, kernel code. The kernel code manages the memory and storage for the database system. The second, repository of metadata. In Oracle, the metadata repository is called a data dictionary. The data dictionary is structured in tables and views and contains information about the database, such as the definition of all schema objects, for example, tables, views, indexes, your procedures, packages, triggers, etc. It contains the space allocated for and currently being used by your schema objects. It contains default values for columns. It contains integrity constraint information. It contains the names of the Oracle users and their privileges and roles that are granted to them. Auditing information is stored in the data dictionary, as well as other general database information. The third element is query language. This language enables applications to access the data. In the case of Oracle, SQL is used, structured query language. The major aspects of the relational model are structures. Well-defined objects store or access the data of a database. Operations. Clearly defined actions enable applications to manipulate the data and the structure of the database. And integrity rules. Integrity rules govern operations on the data and on the structures of the database. In our final slide, a relational database is a collection of relations or two-dimensional tables that are controlled by the Oracle server. So in the example on this slide, we have an employees table which contains information pertaining to the employee. In the departments table, we have information that pertains specifically to the departments table. In today's lesson, we looked at the components of the relational model, and we looked at the elements that make up the database management system. Models are the cornerstone of design. As engineers would build a model of a car to work out any details before putting it into production, in the same manner, system designers develop models to explore ideas and to improve the understanding of the database design. A model helps to communicate concepts that are in people's minds and can be used for the following: to communicate, categorize, describe, specify, investigate, evolve, analyze, and initiate. The objective is to produce a model that fits a multitude of these uses. The model should be understood by the end user and contain sufficient detail for a developer to build a database system. A data model is the first step in a database design, and the data model starts with a conceptual model. It then evolves into a logical model, and then finally into a physical schema. A conceptual model is made up of concepts, and it is used to help people understand and simulate the subject that is represented by the model. A logical model describes in as much detail as possible the data. This is based on the conceptual model. The logical model includes entities and the relationship among them, including the attributes for each entity. Lastly, we build a physical schema that is based on a logical model. A physical schema is the description of how data is stored in the database management system. For example, in tables, indexes, constraints, and so on. The Oracle SQL Developer Data Modeler is a free tool provided with Sql Developer. It is provided to enhance productivity and to simplify data modeling tasks. Looking now at some of the features of the Oracle SQL Developer Data Modeler. With the Data Modeler, users can create, browse, and edit logical, relational, physical, multidimensional, and data type models. One can forward engineer a logical model into a physical model, and reverse engineer by taking a physical model and generating a logical model. The Oracle SQL Developer Data Modeler can be used in both a traditional and cloud computing environment. In this video, we covered the data model, describing the three main components: the conceptual model, the logical model, and physical design. In an effective system, data is divided into discrete categories or entities. An entity relationship model is an illustration of the various entities in a business and the relationships among them. An ER model is derived from business specifications or narratives and is built during the analysis phase of the system development lifecycle. ER models separate information required by a business from the activities performed within the business. Although businesses can change their activities, the type of information tends to remain constant. Based on that, the data structures tend to remain constant. Some of the benefits of ER modeling are: it documents information for the organization in a clear, precise format. It provides a clear picture of the scope of the information required. It provides an easily understood pictorial map for database design. And lastly, it offers an effective framework for integrating multiple applications. The components in an ER model are: an entity is an aspect of significance about which information must be known. Examples are departments, employees, and orders. The attribute is something that describes or qualifies an entity. For example, for the employee entity, the attribute will be the employee number, name, job title, hire date, department number, and so on. Each of the attributes is either required or optional. This state is called optionality. A relationship is a named association between entities, showing optionality and degree. An example is the relationship between the employees and departments table. To represent an entity in a model, use the following conventions: a singular, unique entity name. Entity name must be in uppercase. use a softbox. Optional synonym names in uppercase with parentheses. To represent an attribute, use the following conventions: a singular name in lowercase, an asterisk tag for mandatory attributes. These values must be known. A capital letter O tag for optional attributes. These values may be known. Looking now at relationships. Each direction of the relationship contains the following: a label. An example would be taught by or assigned to. An optionality. Either it must be or may be. And thirdly, a degree. Either one and only one or one or more. The symbols in an ER model are dashed line. This defines an optional element indicating maybe. Solid line defines a mandatory element indicating must be. The crow's foot, the degree element indicating one or more. A single line, the degree element indicating one and only one. Some final notes. The term cardinality is a synonym for the term degree. Each source entity may or must be in a relation to one and only one or more with the destination entity. When reading an ER diagram, the convention is to read clockwise. A unique identifier is a combination of attributes or relationships or both that serve to distinguish occurrences of an entity. And lastly, each entity occurrence must be uniquely identifiable. Tag each attribute that is part of the UID with a hash sign, and tag the secondary UIDs with a hash sign in parentheses. In this lesson, we described an entity relationship model, we looked at the components of an ER model, and the conventions. Each table contains data that describes exactly one entity. An example of this is the Employees table. It contains information about the employees. Categories of data are listed across the top of each table. For example, in the Employees table, this would be the employee ID, first name, last name, and department ID. The individual cases are listed below. An example of this would be the employee ID is 100, the first name Stephen, last name King, and the department ID of 90. Each row of data in a table can be uniquely identified by a primary key. By using a table format, you can readily visualize, understand, and use information. Data about different entities is stored in different tables, and you may need to combine two or more tables to answer a particular question. For example, you may want to know the location of the department where an employee works. To do this, you need information from the Employees table and the Departments table. In a relational database, we can relate data in one table to data in another table by the use of foreign keys. A foreign key is a column or set of columns that refers to the primary key in the same or another table. The example in the slide shows the Employees and Departments table. The Departments table has a primary key on the Department ID column. In the Employees table, we have a column containing the Department ID to which the employee belongs. We create a foreign key on this Department ID, which in turn refers back to the primary key on the Departments table. The ability to relate data in one table to data kept in another allows you to organize information into separate manageable units. The employee data can be kept logically distinct from the department data by storing it in separate tables. Some guidelines when creating primary and foreign keys. You cannot have duplicate values in a primary key. The primary key generally cannot be changed. Foreign keys are based on data values, and they are purely logical pointers. A foreign key value must match an existing primary key value or unique key value, otherwise it should be null. And lastly, a foreign key must reference either a primary key or a unique key column. In our Sql Developer session, we have opened up the definition of the Employees table, and we clicked on the Model tab. This screen shows the entity relationship diagram, showing all relationships between tables and the employees table. Between the employees table and the departments table, we have a one-to-many relationship. We have a foreign key constraint for department ID on the employees table, and this references the primary key for the departments table. In this video, we've covered how multiple tables relate to each other. In this lesson, we are going to discuss relational database terminology. In an Oracle relational database, we have a user, the HR user, and the HR user owns objects such as tables, indexes, and so on. When the HR user creates objects within the database, the metadata is known as a schema. A schema defines attributes of the database, such as tables, columns, and properties. A schema will exist per database user that has created objects in the database. A relational database can hold one or more tables. A table is the basic storage structure of a relational database and holds all the data necessary about something in the real world, such as employees, invoices, and customers. In this slide, we show the contents of the employee table. The numbers in the slide indicate the following. Number 1 shows a single row representing all the data required for a particular employee. Each row in a table should be identified by a primary key. A primary key permits no duplicate rows. The order of the rows is insignificant, as we will specify the row order when the data is retrieved. Number 2 shows a column or attribute containing the employee number. This number identifies a unique employee in the employees table. In this example, the employee number is designated as the primary key. A primary key must contain a value, and the value must be unique. Number 3 shows a column that is not a key value. A column represents one kind of data in a table. In this example, the data is the salaries of all employees. Number 4 shows a column containing the department number, which is also a foreign key. A foreign key is a column that defines how tables relate to each other and refers to a primary key or unique key in the same table or in another table. In this example, the department ID uniquely identifies a department in the departments table. In number 5, a field can be found at the intersection of a row and a column, and there can only be one value in it. In this slide, we give an introduction to some of the Oracle database objects. The first is an index. An index is a database object intended to improve the performance of select queries. Next, we have partitions. Partitioning allows a table, index, or index-organized table to be subdivided into smaller pieces. Each piece of the database object is called a partition. Each partition has its own name and may optionally have its own storage characteristic. Views. A view is a representation of a SQL statement that is stored in memory so that it can be reused. A view is a logical entity or logical table that is essentially a SQL statement stored in the database in the system table space. Sequences. The Oracle sequence function allows you to create auto-numbering fields by using sequences. An Oracle sequence is an object that is used to generate incrementing or decrementing numbers. Next, synonyms. In Oracle Pl Sql, the term synonym refers to a schema object which is created by a user to access an object that is owned by another user. In the process of creating a synonym, the user seeking the object access must first create a synonym for the required object. The owner user must then grant access on the synonym to the seeking user. Lastly, we look at Pl Sql subprograms and packages. In Pl Sql, a package is a group of programmatic constructs combined into a single unit. In this lesson, we discussed the relational database terminology, we looked at the table structure, and we introduced some Oracle database objects. Today's lesson is an introduction to SQL and the development environment that will be used in the learning path. In a relational database, we do not specify the access route to tables, and we do not need to know how the data is arranged physically. SQL is a set of statements which all programs and users can use to access data in the Oracle database. SQL is an ANSI standard for using relational databases and is compliant with the ISO standard SQL 1999. It is efficient and easy to learn and use. Applications and Oracle tools allow users to access the database without using SQL directly. These applications, in turn, must use SQL when it executes the user's request. The tasks that can be performed using SQL, these include querying data, insert, update, and delete of rows in a table. We can create, replace, alter, or drop objects. We can control the access to the database and its objects. SQL statements guarantee database consistency and integrity. SQL combines all the tasks listed into one consistent language, and it thereby enables you to work with data at a logical level. The SQL statements supported by Oracle comply with industry standards, and Oracle ensures future compliance by actively involving key personnel in the SQL Standards Committee. These industry-accepted committees are ANSI and ISO. Both have accepted SQL as the standard language for relational databases. Looking now at the SQL statements. The select, insert, update, delete, and merge statements. These retrieve data from the database, enter new rows, change existing rows, and remove unwanted rows from tables in the database. And it is collectively known as Data Manipulation Language, or DML. The second set of statements: create, alter, drop, rename, truncate, comment. These set up, change, and remove data structures from tables. It is collectively known as Data Definition Language, or DDL. The grant and revoke statements provide or remove access rights to both the Oracle database and its structures, also known as Data Control Language, DCL. The commit, rollback, and save point statements. These manage the changes made by DML statements. Changes to the data can be grouped together into logical transactions. In this learning path, we will make use of two development environments provided by Oracle. The first is Sql Developer. This will be the default tool that we will use for running the SQL statements in our learning path. The second is Sqlplus. Sqlplus can also be used to run all SQL commands covered in this learning path. We will learn the features and functions of both SQL Developer and Sqlplus in upcoming lessons in the learning path. In today's lesson, we provided an introduction to SQL and the development environments that will be used throughout this learning path. In today's lesson, we're going to discuss the sample schemas provided with the Oracle database and specifically the HR schema which we will use throughout this learning path. The Oracle database provides a set of interlinked sample schemas. Some of these schemas are HR, OE, OC, PM, IX, and SH. The sample schemas are based on the following design principles: simplicity and ease of use, relevance for typical users, and on extensibility. These sample schemas are based on a fictitious sample company that sells goods through various channels. The company operates worldwide to fill orders for products and has several divisions, each of which is represented by a sample schema in the database. The HR schema is the Human Resources division, and it tracks information about the company, employees, and facilities. Next, the OE schema. This is the Order Entry division, and it tracks product inventories and the sales of products through various channels. The PM schema is the Product Media division, and it maintains description and detailed information about each product sold by the company. The IX schema is the Information Exchange division. It manages shipping through B2B applications. The last schema we will discuss is the SH schema. This is the sales division, and it facilitates business decisions by tracking business statistics. Depending on how the database is created, these schemas may or may not exist in the database. It is not recommended for these schemas to be created in a production environment. Should the sample schemas not exist, they can be installed manually, taking into consideration that due to dependencies between the schemas, they will need to be created in a specific sequence. Refer to the Sample Schemas Guide in the Oracle Database online documentation for how to install these schemas. In this learning path, we will make use of the Oracle Human Resources Sample Schema. The HR schema consists of the following tables. We start with the Regions table. This contains rows representing regions, for example, America and Asia. The Countries table contains rows for each country associated with a region. In the Locations table, this contains address of specific offices, warehouses, and production sites of the company in a particular country. The Departments table shows details about the departments in which the employees work. The Employees table contains details about each employee working in a department. Some employees may not be assigned to any department. The Jobs table contains job types that can be held by an employee. Lastly, we look at the Job History table. This contains a job history for the employees. When an employee changes departments within a job or changes jobs within a department, a new row is inserted into this table. Looking now in a bit more detail at some of the tables. The first table we will look at is the Countries table. In the top block, you will see the definition of the table, and in the bottom block, you will see the data that exists in this table. So in the Country table, we have a country ID, we have a country name, and the region ID. The next table is the Departments table. In the Departments table, we have the Department ID, the Department name, the Manager ID, and the Location ID. The last table we will look at is the Employees table. This table holds all the information specific to an employee, such as your employee ID, their first and last name, their email address, a phone number for the employee, a hire date, a job ID, their salary, a commission percentage, the manager ID, and the department ID. In today's lesson, we discussed the Oracle-provided sample schemas and looked at the HR schema, which we will be using throughout this learning path. Oracle provides a free graphical tool called Sql Developer. It is designed to improve your productivity and to simplify the development of everyday database tasks, such as you can browse and manage database objects, you can execute SQL statements and scripts, you can edit and debug Pl Sql statements, and create reports. With Sql Developer, you can connect to any Oracle target database using standard Oracle database authentication. Some of the new features within Sql Developer are: Sql Developer is the interface to manage Oracle Application Express Listener. This enables you to specify global settings and multiple database settings with different database connections for the Application Express Listener. You now have the option to drag and drop objects by table or column name onto the worksheet. Sql Developer now also provides improved database diff comparison options, grant statement support in the SQL editor, and database doc reporting. It also includes support for the Oracle Database 12c features. From Oracle Database 12c Release 1, Sql Developer is now shipped by default with the database software. Sql Developer is developed in Java, and it is a cross-platform tool. It runs on Windows, Linux, and Mac platforms. The default database connection method is through the JDBC driver, and therefore no Oracle Home is required. For the installation, you simply unzip the downloaded file and run the executable to start Sql Developer. Sql Developer users can connect to Oracle databases from version 9.2.01 and later. It also includes all database editions, including the Express edition. The SQL Developer interface contains three main navigation tabs. The first is Connections. Using this tab, you can browse the database objects and users to which you have access. The next is the Reports tab. This tab allows you to run predefined reports and to add your own reports. Then there's the Files tab. In this tab, you have access to the files from your local machine without having to use the File Open option. SQL Developer uses the left side for navigation to find and select objects and the right side to display information about the selected objects. Many aspects of the appearance and behavior of SQL Developer can be customized by setting your preferences. Lastly, you need to define at least one connection to be able to connect to a database schema and to issue SQL queries. In this SQL Developer session, we have a connection to the ORCL database. You can see the list of tables that we have access to. The Reports tab is below with the default reports. On the right-hand side is a SQL statement that I've issued against the database, and below the results of that query. In today's lesson, we introduce SQL Developer. We discuss the specifications for SQL Developer and introduce the SQL Developer interface. In today's lesson, we're going to set up a database connection within SQL Developer. In order to work in SQL Developer, you will need to have at least one database connection. You can create and test connections for multiple databases and multiple schemas. SQL Developer will automatically import any connections defined in the tnsnames.oro file. The default location for this file is in the Oracle Home Network Admin directory, or in the location specified by the tns_admin environment variable. You are able to export your connections to an XML file, and additional connections can be created as different users to the same database or to connect to different databases. We can also set up connections to non-Oracle data sources, such as Access, MySQL, and SQL Server. These connections are, however, read-only connections. When creating a database connection, we will create a new connection. We will specify the connection criteria, and that will log us into our database, and we will be able to view the database objects. I'm now going to take you to a SQL Developer session where we will create the new database connection. Double-click on your SQL Developer icon. This will log us into SQL Developer. On the Connections tab, right-click, select New Connection. For the new connection, we will specify a connection name. I'm going to call it the same as the database name. The username and password, this will be the database username and password. You are able to save this password, so when you log in future, you don't have to specify the password. There are several connection types. The first of these is basic. For the basic connection type, you will enter the host name, the port, and the database SID or service name. The next connection is a TNS option. For the TNS option, you can select any one of the database aliases imported from the TNS names file. For the LDAP option, you are able to look up the database service in the Oracle Internet Directory. The Advanced option, this allows you to define a custom JDBC URL to connect to the database. For the local bequeath connection type, the database and the client exist on the same computer. The client connection is passed directly to a dedicated server process without going via the listener. In today's lesson, we're going to use the basic connection type. For the role, you can specify whether you need to connect as a sys user or as the default. We're going to leave it at default. We will specify the host name, and I'm going to specify the IP address of the server where the database is located. The port number, we will leave as the default port number, and we will specify the Oracle SID. We will test our connection. If the connection fails, you will need to address the error and then retest your connection. Once the status shows success, we will then be able to connect to the database. Once we are connected, we will see under Connections we have connection to the ORCL database. If I click on the plus sign, we will now be able to see the objects that we have access to. So I can see a list of tables. In today's lesson, we set up our connection to our database within SQL Developer. In today's lesson, we are going to browse database objects, we will describe a table structure, and we will use File Navigator to browse files on the file system. We have created our database connection and have connected to the database. We can now use Connection Navigator to view objects such as tables, views, indexes, packages, and triggers. SQL Developer uses the left side for navigation to find and select the object, and the right side to display information about the selected objects. You can see the definition of the objects broken down into tabs of information pulled out of the data dictionary. For example, if you select a table in the navigator, details about the table's columns, constraints, grants, statistics, triggers are displayed on an easy-to-read tabbed page. We can also display the structure of a table using the Describe command. This command will display the column names and data types for the table, including if a column should contain data. In SQL Developer, we can use File Navigator to browse and open files on the local system. To do this, we can either click on the Files tab or select View and then select Files. To view the contents of a file, double-click on the file name and the contents will be displayed in the SQL Worksheet area. We are now in SQL Developer, and in our first example, we are going to open our HR connection, and we will be able to see in the drop-down list the types of objects that we can access. Within tables, we can see the tables that exist within the HR schema. If we click on a table, on the right-hand side we will see information regarding that table, such as a definition of the columns within the table. We can view the data within that table. We can view information around the table, such as constraints, grants, statistics, and triggers. In our second example, we are going to describe a table. So we go to our SQL Worksheet area and we type Describe and the table name. We will then execute that command, and this will return the definition of the table. We will see a list of the column names. This will show us where the data must be entered into those columns, and this will show us the data types. Lastly, to browse files on your local system, we will either click on the Files tab, or we can go View and select Files. You select the file that you would like to open by double-clicking on the file, and this will open the contents on the right-hand side of the screen. In today's lesson, we browsed database objects, we described a table, and we viewed the contents of a file in SQL Developer. In today's lesson, we're going to create a schema object in SQL Developer. This is to demonstrate the functionality within SQL Developer. The creating of tables will be covered in more detail during a future lesson in this learning path. SQL Development supports the creation of any schema object by executing a SQL statement in a SQL worksheet or by using the context menus. Once the object is created, you can then edit the object by using the Edit dialog box. When creating new objects or editing existing objects, the DDL for those objects are available for review. An export DDL option is available should you want to create the full DDL for one or more objects in the schema. The example in the slides will show how to create a table using the context menu. To create a table, right-click Tables and select New Table. The dialog box to create and edit database objects will have multiple tabs, each reflecting a logical grouping of properties for that type of object. In the Create Table example, if the Advanced checkbox is not selected, you can create a table quickly by specifying the column names and some frequently used features. If selecting the Advanced checkbox, the Create Table dialog box changes to one with multiple options, in which you can specify an extended set of features when creating the table. In this example, the slide shows how to create the dependence table by selecting the Advanced checkbox. The steps to create a new table are: in the Connection Navigator, we right-click on Tables and select Create Table. In the Create Table dialog box, select Advanced, specify the column information, and then click the OK button. Although it is not required, you should specify a primary key by using the Constraints tab in the dialog box. To edit an existing table, right-click on the table in the Connection Navigator and select Edit. So from within Sql Developer, we're now going to create a table. On the Tables tab, we're going to right-click and select New Table. The first thing we'll do is we'll give it a table name. We're going to create a simple table in this example, so we'll deselect the Advanced option and we'll enter our column names. We'll give it an ID. I'm going to make this a data type number and give it a size 10. We'll then click on the plus button to add a second column. Give it a name. And once we've completed all our columns, we will click on the OK button and our table will be created. Now we click on the table's plus sign. We can see our dependent table has been created, and on the right-hand side you can see the definition of the table. We did not create any constraints on this table, so to edit the table we're going to right-click on the table and click Edit. This will open up the definition of the table. We will go to Constraints and we will add a new constraint. We're going to add a primary key constraint. The name and enabled are set by default. We will select the column that we wish to have the constraint on, and we will click OK. If we now go to the Constraints tab, we will see that we have a primary key constraint defined and a check key constraint. The check key constraint is to show we cannot have a not null condition on a primary key. For our second example, we're going to create a table with using the Advanced option. So we go back to Tables, we right-click, we say New Table, we give our table a name. We will check the Advanced button. We will then enter our column names. We'll give it an ID, and we will add a second column, which we'll call Grading Name. We'll leave that as a varchar. So now in the Advanced option, we can create our constraints at the same time that we create the table. So to do that, we click on the plus sign, we add a new primary key constraint. We select the column that we wish to have the constraint on, and we click on the OK button. So having a quick look at the grading table, we can see the definition of the grading table on the right-hand side, or at least this is the constraints that are defined for the grading table. We can see the columns that are defined. In today's lesson, we're going to introduce the Sql Worksheet window and the icons available on this window. When connecting to a database, a Sql Worksheet window is automatically opened. You can then use this window to enter and execute Sql, Pl Sql, and Sqlplus statements. The Sql Worksheet supports Sqlplus statements to a certain extent. Statements that are not supported are ignored and not passed to the database. Some of the actions that can be processed by the database connection are: you can create a table, insert data, create and edit a trigger, select data from a table, and you can save the selected data to a file. The SQL worksheet can be accessed by either clicking on Tools and selecting SQL Worksheet, or by clicking on the Open Worksheet icon. We are now going to look at the icons available on the Sql Worksheet Toolbar. The first icon is the Run statement. It executes a statement where the cursor is located in the Enter SQL Statement box. Bind variables can be used, but no substitution variables. The second is Run script. This executes all statements in the Enter SQL Statement box. Substitution variables can be used, but not bind variables. Thirdly is the Autotrace. This icon generates trace information for the statement. The fourth icon is Explain Plan. It generates the execution plan, and you can view this by clicking on the Explain tab. The fifth icon is the SQL Tuning Advisory. It analyzes high-volume SQL statements and offers tuning recommendations. Number 6 is the Commit. The commit writes changes to the database and ends the transaction. Icon number 7, the Rollback icon, discards changes to the database without writing them and then ends the transaction. The Unshared SQL Worksheet icon creates a separate unshared SQL worksheet for a connection. Icon number 9 changes the selected text to uppercase, lowercase, or init cap respectively. Icon number 10 is the Clear icon. This erases the statements in the statement box. Lastly, we have the SQL History icon. This displays a dialog box with information about the SQL statements that you have executed. All SQL and PL/SQL commands are supported, and they are passed directly from SQL Worksheet to the database. The Sqlplus commands used in Sql Developer must be interpreted by the SQL Worksheet before being passed to the database. Sqlplus commands not supported by SQL Worksheet are ignored and not sent to the database. On the SQL Worksheet screen, enter the SQL statement at the top section, execute the statement, and the results are shown in the Results tab in the bottom section. Lastly, in this slide, we're going to show you the Sql Developer feature for formatting SQL code. This feature will format the indentation, spacing, capitalization, and the line separation. To format SQL code, right-click in the statement area and select the Format option. In today's lesson, we introduced the Sql Worksheet window. We looked at the function of the icons available on the Sql Worksheet window, and we introduced the SQL code formatting feature. In this lesson, we are going to execute SQL statements in the SQL Statement window, and we are going to save a SQL script in Sql Developer. The SQL Statement window is used to enter single or multiple SQL statements. To execute a single SQL statement in the SQL Statement window, you can either click on the Run statement icon or press F9. To execute all SQL statements in the SQL Statement window, you can click on the Run script icon or press F5. An example of the output results are displayed in this slide. For the run of a single statement, the Query Result window will show the output of the SQL statement. When running all SQL statements, the Result Query window will show the output for all of the SQL statements. To save your SQL statements entered in the Sql Worksheet window, there are 3 available options. The first is by clicking on the Save icon. The second is to select File and then select the Save menu item. And lastly, you can use the shortcut key, Ctrl+S, and this will open the Save dialog box. In the Save dialog box, enter the file name and the location where the file is to be saved, and click on the Save button. We are now in our Sql Developer session, and we are connected to our HR schema. In the SQL Statement window, we have 2 SQL statements that we would like to execute. To execute only one of these statements, ensure the cursor is on the line to be executed and click on the Run Statement icon. The output is shown in the Query Result tab below. To execute all SQL statements within the SQL Statement window, click on the Run Script icon. The output is shown in the script output below. The data will be returned for both select statements. Here you can see we have the output for our employees table, and below that we have the output for the departments table. Looking now at saving a SQL script, the options are: you could click on the Save icon. This will open the dialog box. The second option is to click on File, Save. This too will open the Save dialog box. The third option is to use the shortcut key, Ctrl+S. This also opens the dialog box. Type in the name of the SQL script and the location where you wish to save your file. And when you're ready, click on the Save button. In this lesson, we executed a single SQL statement from within the SQL Statement window. We then executed all SQL statements in the SQL Statement window. And lastly, we looked at the options to save our SQL script. In this lesson, we will look at two methods for executing saved script files. The first method, open the script file from the File Navigator, or you can click File, Open, and then navigate to the script file that you want to open. You can then double-click on the file to open it. The code will be shown in the Sql Worksheet area. To run the code, click on the Run Script icon or press F5 or F9. If you have not selected a connection from the connection drop-down list, a connection dialog box will appear, and you can then select the connection that you want to use for the script execution. The second method available for executing a saved script file is to enter the full path and name of the script in the worksheet area and prefix it with the @ sign. You can then click on the Run Script icon to execute the script. The results will be displayed in the script output page. The output can be saved by clicking on the Save icon on the script output page. We are now in our SQL Developer session, where we will demonstrate the two methods for executing a saved SQL script file. In the first method, we will go to the File Navigator, navigate to the file that you wish to open, and then double-click on the file. The script will open in a new tab in the SQL Worksheet area. To execute the script, click on the Run Script icon. As we have not specified a connection where we wish to run the script, the Select Connection dialog box has appeared. We will select our connection, click on OK, and our script will execute. The output of the script is displayed below in the script output window. In the second method, we go to a blank SQL Worksheet window and we enter the path and the name of the script that we wish to execute. Remember to enter a @ sign at the beginning of the script. Our file is in Skillsoft, Scripts, and it is called hr.sql. When you are ready, click on the Run Script icon. Once again, the output of the script will be displayed in the script output page below. Should you wish to save the data generated by the script, you click on the Save button, and the Save dialog box will appear. You can then navigate to the directory where you wish to save your file, give it a file name, we will call ours hroutput.txt, and we will click on the Save button. In this lesson, we looked at the two methods for executing a saved script file in SQL Developer and how to save the output of a script file. In this lesson, we will look at how to use the SQL Developer feature called Snippets. When using SQL worksheets or creating and editing PL SQL functions or procedures, you may want to use certain code fragments. Snippets are code fragments such as SQL functions, optimizer hints, and miscellaneous programming techniques. These snippets can be dragged onto the editor window. To display snippets, click on View and then select Snippets. The Snippets window will be displayed on the right-hand side of the screen, and you can then use the drop-down list to select a group. In this slide, we see an example of a list of aggregate functions that are available for use. A snippet button is located in the right window margin. Click on it to display the snippets window, should it become hidden. In this slide, we show an example where we insert a snippet into our SQL statement and how to edit a snippet. To insert a snippet into your code in a SQL worksheet or Pl Sql function or procedure, drag the snippet from the snippets window to the desired place in your code. You can then edit the syntax so that the SQL function is valid in the current context. To see a brief description of a SQL function in a tooltip, place the cursor over the function name. The example shows the concat function. It is dragged from the character functions group in the snippets window, and the function syntax is then edited. Once edited, add the rest of the SQL statement and then execute your query. We are now in our SQL Developer session, where we will demonstrate the use of snippets. To open the Snippets window, click on View and select Snippets. The Snippets window will appear on the right. We will now create a select statement from the Employees table using the concat function from the Snippets window, and we will then execute the SQL statement. In our SQL Worksheet window, we start by typing our select command. We then go to our Snippets window and we select the character functions and we select the concat function and we drag it across onto our worksheet. We then edit the concat function with the valid column names. So we'll use first name and we're going to concatenate it with the last name. We'll then complete our SQL statement. So we're going to select from the Employees table. When our statement is completed, we'll execute the SQL statement. As you can see below in the result query output, we have our data returned and it has been concatenated. To see a brief description of a SQL function in a tooltip, place the cursor over the function name in the snippets window and the description will be displayed. Lastly, in the drop-down list, you can see the list of groups which contain functions, optimizer hints, and miscellaneous programming techniques. In this lesson, we introduced the SQL Developer feature called Snippets. In this lesson, we're going to take a look at the recycle bin in SQL Developer. The recycle bin is a data dictionary table that contains information about objects that have been dropped in the database. Drop tables and any associated indexes, constraints, nested tables, and the like are not removed and still occupy space. This continues to count against the user space quotas until it is specifically purged from the recycle bin, or in the unlikely situation where these objects must be purged by the database due to table space constraints. To use the recycle bin, in the Connections Navigator, select Recycle Bin. Expand the recycle bin, click on the object name, and the object details are displayed in the SQL Worksheet area. You can then click Actions, drop-down list, and select the operation that you want to perform on the object. There are two actions available. The first one is Purge. This removes the object from the recycle bin and deletes it from the database. The Flashback to Before Drop option moves the object from the recycle bin back to its appropriate place in the Connections Navigator display. We are now in our SQL Developer session, where we will demonstrate the actions available when working with objects in the recycle bin. To get started, click on the plus sign next to your connection in the Connection Navigator drop-down list, open the recycle bin, and list the objects that exist currently in the recycle bin. Click on the table with which you want to work, and the details for the table will be displayed in the SQL Worksheet area. There are two available actions when working with the objects in the recycle bin. The first is to purge the object from the recycle bin, and the second is to flashback to before drop. When we purge the table from the recycle bin, the associated objects are purged at the same time. In our session, we clicked on the emp backup table, and we're now going to select Purge. We're going to delete this table from the database. The Purge box will appear, and we click on the Apply button. We then receive a confirmation that the table has been purged. All associate objects will be purged at the same time that the table is purged. We click on OK, and you will see that our table no longer exists in the recycle bin. Looking now at the flashback to before drop option, we're going to click on the grade backup table, and this will open the details of the table in the Sql Worksheet area. We will then go to our actions, and we will select flashback to before drop. The flashback to before drop box will appear, and we then have the option of giving it a new name. We will call it grade back restore, and we will click the Apply button. We will then receive a confirmation that the flashback is complete. We can now see that this table no longer exists in the recycle bin. The table has been moved back to the Tables section. So if we open Tables, we need to refresh Tables, and we can find our grade back restore table. The index, all objects are given a unique system-generated name when they are moved to the recycle bin. In this lesson, we introduced the recycle bin and demonstrated the actions available when working with objects in the recycle bin. Sql Developer can be used to debug Pl Sql procedures and functions. To debug a procedure within Sql Developer, we use the Compile for Debug option to perform the Pl Sql compilation. The debug menu options can be used to set breakpoints and to perform step into and step over tasks while debugging your procedures and functions. The following debugging tasks are available on the debugging menu. First, find execution point. This goes to the next execution point. Resume continues with the execution. The step over task bypasses the next method and goes to the next statement after the method. Step into goes to the first statement in the next method. Step out leaves the current method and goes to the next statement. The step to end of method goes to the last statement in the current method. Pause halts the execution but does not exit, thereby allowing you to resume the execution. Terminate. This halts and exits the execution. You cannot resume an execution from this point. Instead, to start running or debugging from the beginning of the function or procedure, click on the Run or Debug icon on the Source tab toolbar. Lastly, there is the Garbage Collection option. It removes invalid objects from the cache in favor of more frequently accessed and more valid objects. The options mentioned are available as icons on the Debugging tab of the Output window. In our Sql Developer session, we will show you how to get started with debugging your procedures and functions, and we will in addition discuss some of the privileges required in order to make use of debugging. The privileges required to allow you to make use of the debugging functionality are: you must be granted the Debug Connect session privilege. You must be granted execute privilege on the DBMS Debug JDWP package. We must ensure the user has execute privilege on the stored procedure that you wish to debug. And we need to make sure that the stored procedure is compiled for debug. To get started, navigate to the procedure to be debugged. Right-click on the procedure and select Compile for Debug. A green bug will appear over the icon next to the procedure name. To start the debug, there are two options. You can either click on the icon on the toolbar, or we can right-click on the procedure and we can select Debug. This will open the Pl Sql Debug window, and you can then continue with the debugging procedure. Should you not have set breakpoints for debugging, you can select the Step Over option in the Sql Developer Preferences. You are now ready to start debugging your procedures and functions within Sql Developer. In this lesson, we're going to look at the database reporting feature available within Sql Developer. Sql Developer provides many predefined reports about the database and its objects. These reports can be grouped into the following categories: about your database, database administration reports, table, PL SQL, security, XML, jobs, streams reports, all object reports, data dictionary reports, and user-defined reports. To display reports, click on the Reports tab and then drill down to the required report. Click on the report to execute it. The results will be displayed in the Sql Worksheet area. We are now in our Sql Developer session, where we will look at the predefined reports available in Sql Developer. Click on the Reports tab and a list of report groups will open. These reports are provided by default with Sql Developer. Some reports require additional privileges to run, and you will encounter an error should you attempt to run these reports without the required privileges. Drill down to the report that we want to run. We'll go to the Data Dictionary reports. We'll open up the About Your Database, and we're going to run the National Language Support Parameters report. So we click on our report. It'll prompt us for a connection. We'll click on OK. We're connecting to the HR connection. And the output of the report will be displayed in the Sql Worksheet area. Looking now at some of the other reports available within the Data Dictionary reports, we can view reports about the objects within the database. We can view database administration reports, so we could see our alert log. We could look at database parameters, locks, memory, session information. We could look at the top SQL. Within the remaining groups, we have the Data Modeler report. So if you're using the Data Modeler, there are default reports provided for that. Should you be using OLAP, there are default predefined reports for OLAP that are available to be used. The same for times 10. There are some times 10 reports for a times 10 environment. Lastly, we have the user-defined reports. Here we can write our own custom reports, and in our next lesson, we will cover the steps on how to do this. Lastly, we're going to look at a report where we do not have the required privileges. So in our example, we're going to go back to Data Dictionary reports, and we're going to go down to Security and to the Audit Policies report. When we click on the report, we get this error, the error 00942, table or view does not exist. This indicates to us that the HR user does not have the necessary privileges within the database to access this report. In this lesson, we introduce the reporting feature within Sql Developer. In this lesson, we're going to create a user-defined report within the database reporting feature that is available within Sql Developer. User-defined reports are reports created by Sql Developer users. To create a user-defined report, right-click the User-Defined Reports group under the Reports tab and select New Report. In the Create dialog box, specify the report name and the SQL query to retrieve the information for the report. When completed, click on the Apply button. In the example in the slide, the report name specified is emp_cell, and the complete SQL statement is specified in the SQL box. You can include an optional tooltip to be displayed when the cursor stays briefly over the report name in the Reports Navigator display. The User-Defined Reports folder can be organized into a hierarchy consisting of folders and subfolders. To create a folder, right-click on the User-Defined Reports option and select New Folder. Information about the user-defined reports, including any folders for these reports, is stored in a file named userreports.xml in the directory for user-specific information. We are now in our Sql Developer session, where we will create a user-defined report in Sql Developer. Firstly, we're going to create a folder under the user-defined reports. Right-click, Create New Folder. Give the folder a name. We're going to call ours Employees and enter a description. We can then add in a tooltip. We're going to call ours Employee Maintenance Report and we click on the Apply button. We are now going to create a report in our Employees folder. So we'll right-click on the Employees folder. We will select New Report. The Create Report dialog box will be opened. The first thing we'll do is give the report a name. So we will call it emp_cell. Then we can select different styles of reports. We could have a table, a chart, a gauge, code, script, or Pl SQL DBMS output. For this exercise, we're going to leave it as table. We'll then put in a description for our report. So this report is going to display all employees with a salary greater than 10,000. We will then add in our tooltip. For our tooltip, we'll say employee salary greater than 10,000. The next step is to capture our SQL statement. So we're going to paste our SQL statement into the window below. We're going to select the employee ID, their first name and their salary from the employees table, where they have a salary greater than 10,000. Once all the information has been entered, we click on the Apply button and our report will be created. So if we go back to the Employees folder and we click on the plus sign, we'll see our report. To display the output of our report, we click on our report name. It'll prompt us for a connection, so we will keep our HR connection. We click on the OK button, and the output of the report is displayed in the Sql Worksheet area. So let's do one more exercise. We're going to edit our report. So we'll right-click on the report and select Edit. And we'll change the style to a chart. That's the only change we're going to make, and we click on the Apply button. Immediately, the output in the Sql Worksheet area has changed to a chart. In this lesson, we created a user-defined report within the Sql Developer reporting feature. To enhance the productivity of developers, Sql Developer has added two features. The first, quick links to popular search engines and discussion forums, such as Ask Tom, Google, and so on. The second feature are shortcut icons to some frequently used tools, such as Notepad, Microsoft Word, and File Explorer. You are able to add external tools to an existing list or delete shortcuts to the tools that you do not frequently use. The steps to do this are: from the Tools menu, select External Tools. In the External Toolbox, there are several options. The first option is Find Tools. When you click on this button, it will add frequently used tools to the list. You can then add or remove tools as required. The second option is to add a new tool. Thirdly, you can edit a tool. And lastly, you can delete a tool from the list. In our Sql Developer session, we are going to add icons for frequently used tools to our menu bar. In the Tools menu, select External Tools. This will open up the External Tools dialog box. To quickly add the most frequently used tools, click on the Find Tools icon. The tools that are provided by default are Explorer Directory, Notepad, Mozilla Firefox, Internet Explorer, and Word. You can remove tools that are not frequently used. So in our demonstration, we're going to delete Mozilla Firefox. So we select Mozilla Firefox and we click on the Delete button, and it is removed from our list. We can edit a tool. So if we click on our tool and we click on the Edit button, this will show you the options that you can edit: the path, the display, integration functions within Sql Developer and between the tool, and the availability. We're not going to make any changes, so we're going to cancel. We are now happy with the tools that we've added, so we're going to click on the OK button. Once we do this, you will see that the icons have been added to the toolbar. These icons are currently grayed out, so to make them active, we'll go to our connections and we'll click on our HR connection. And you can now see that these icons are available for use. If you click on the icon, it'll open the relevant program. Sql Developer also provides shortcut links between your database connections. So we're going to close our Notepad session, and on the right-hand side, you will see the connection drop-down box. So you will have a list of all connections to all the environments that you have access to. Now you know how to add icons to the menu bar for your frequently used tools. Many aspects of the SQL Developer interface and environment can be customized by modifying the preferences according to your needs. To access preferences, select the Tools menu and then select Preferences. The preferences are grouped into categories. Some of these categories that you can set preferences for are your environment, code editors, the database, the data modeler, the debugger, external editor, and shortcut keys. Once you have set the required preferences, these can be copied to another SQL Developer environment. Close the SQL Developer sessions and then copy the preferences.xml file to the new SQL Developer environment. Should you need to reset your SQL Developer layout, this may occur when working in SQL Developer and if the connection navigator disappears, or if you cannot dock the log window in its original place. You can perform the following steps to fix the problem. First, exit the SQL Developer session. Then open a terminal window and use the locate command to find the location of the windowing layout.xml file. Go to the location of that file and delete it. You can then restart your SQL Developer session. We are in our SQL Developer session. To open Preferences, we click on Tools and select Preferences. Some settings to consider within SQL Developer are the following. First, we go to Database and we select Worksheet. Within the Worksheet preferences, we will increase the SQL history limit to 500. This is a history of all SQL statements, so we will keep the last 500 SQL statements. Next, we will set the Show Query Result in a new tab. This will open a new tab for Query Output Results. The more open windows, the more memory will be used by SQL Developer. On this screen, we can also set the default location where SQL Developer will look for scripts. Some other settings to look out for under the Database category, we go to Advanced. Here we need to make sure that Auto Commit is deselected. It is not recommended to enable Auto Commit within your SQL Developer session. On this screen, we can also set the default location for our TNS names file. Next, we will go to Licensing. Under Licensing, for each connection, you can enable or disable the Change Management pack, the Tuning and Diagnostics packs. This is to ensure that you do not use the functionality if you are not licensed to use these packs. The next preference we're going to look at is showing line numbers in our SQL Developer session. For this, we will go to the Code Editor and we will select Line Gutter. Under Line Gutter, we will select the first option, Show Line Numbers. Within Code Editor, you can also edit the font, the size, and the type of font used in your SQL Developer session. Next, we will look at setting some preferences that we can use for debugging. So we go to Debugger. On the Debugger screen, we will focus on the Start Debugger option. Ensure it is set to Step Over. This allows you to start and run a debug session without breakpoints. The Step Over option tells SQL Developer to stop the execution at line 1. If it is not set, SQL Developer Debug will look like it is not working and it will run until it finds a breakpoint, breaking condition, or exception. The last preference that we're going to look at is how to set default editors for files with extensions such as JPEG, XLS, XML, and PDF. Within Preferences, we go to External Editor. It lists all the different file extensions that are available, and for these files, we can enter the location of the application that is linked to this file extension type. We looked at setting default preferences for our SQL Developer environment and showed several of the recommended settings to consider. SQL Developer provides an integrated version of the SQL Developer Data Modeler. Using this integrated version of the SQL Developer Data Modeler, You can create, open, import, and save a database design. We can in addition create, modify, and delete data modeler objects. The menu options available in Sql Developer for the data modeler are: the first, File, Data Modeler. This menu option allows you to open, save, and print design models. For the second menu, click on Tools and select Data Modeler. The Data Modeler menu under Tools allows you to specify design rules and preferences, and also provides administration and wizard options. Lastly, the Data Modeler option under View provides navigation and view options. In our Sql Developer session, we open our HR connection, we log into our HR connection, and we're going to select the Employees table. When the definition of the Employees table is open on the right-hand side of the screen, select the Model tab. The Entity Relationship Model for the Employees table and its related tables will be displayed. This model can be copied to Data Modeler by clicking on the Copy to Data Modeler icon. From there, you can modify the Entity Relationship Model by using the Data Modeler functionality. Looking now at the menu options available for Data Modeler, the first option, we go to File, Data Modeler. This allows you to open, save, and print design models. The second option is under Tools, Data Modeler. This will give you access to additional Data Modeler tools, such as allowing you to specify design rules and preferences. Lastly, we select View, Data Modeler. This provides navigation and view options for the Data Modeler. You now know how to access the integrated Data Modeler that is provided with Oracle SQL Developer. Now that you've learned the basics of working with SQL Developer, it's time to put that knowledge to work. In this exercise, you will create a database connection. You will create the hr.cellgrade table, including the following columns: the cellgrade ID with a primary key, the cellgrade name, and cellgrade description column. You will then verify and set the default location for scripts as it is set in Preferences. You will save a SQL statement in a script named imp_report.sql. You will then execute that SQL script. And lastly, you will run a built-in database report named National Language Support Parameters. When you are ready, pause this video, perform the exercise, and when you are done, resume this video and see how I would do it. There are various methods for performing the exercise, and the method I will demonstrate is just one of these methods. The first exercise is to create a database connection in SQL Developer. To do this, we click on the plus sign. We give our connection a name. We then enter a database username and password. We click on our Save button to save our password. I'm going to use a basic connection type. First, we enter the host name or IP address. We enter the port. I will leave it at the default 1521. And I will enter a service name for my database that I'm connecting to. We click on the Test button to ensure our connection is successful, and then we click on Connect. Next, we're going to create the hr.cellgrade table and browse the table definition. To do this, we click on our connection, and we right-click on Tables, and we say New Table. We enter our table name. We then capture the columns that we want to create. Our first column is cellgrade ID. This will be a data type number, size 10. We click on the plus sign to add the next column. This will be cellgrade name. That's a varchar 220. And we'll add our last column. cell grade description. And that is a varchar 100. We will add our primary key by clicking on the PK column next to the cell grade ID. When we are done, we click on the OK button, and our table has been created. To view the table definition, we click on the plus sign next to tables. We click on our table name, and on the right-hand side, we can see the definition of our table. If we click on constraints, we can view the primary key that was created. Next, to verify the default location for scripts as it is set in Preferences, we click on Tools, we select Preferences. Within Preferences, we click on the plus sign next to Database, and we select Worksheet. On the right-hand side, we can see the default path for scripts. Ours is set to C:*scripts. Once you've set the path, click on the OK button to save it. To save a SQL statement in a script, in our Sql Worksheet window, we've entered a SQL statement. We're going to select Star from Employees. We will execute our script to ensure that it runs correctly. Once we are happy with our script, to save it, we click on the Save icon. We will be prompted to give our script a name. We will call it emp_reports.sql, and we will click on Save. Our script has now been saved. To execute a SQL script, we're going to open a new Sql Worksheet window. So we right-click on our connection. We say Open a SQL Worksheet. And in our SQL Worksheet, we enter the @ sign and the name of our script. This will look in the default location that we defined. We can then execute our script, and the output is displayed in the script output window below. Lastly, we're going to run a built-in database report. To do this, we click on the Reports tab. We drill down to our report under Data Dictionary Reports and About Your Database. To run the National Language Support Parameters report, we simply click on the report. We will be prompted for a connection. We will connect to our PDB ORCL connection. Click on OK. And the report is executed and the output displayed on the right-hand side. In today's video, we're going to introduce the Oracle tool Sqlplus and discuss the interaction between SQL and Sqlplus. SQL is a command language used for communication with the Oracle server from any tool or application. When you enter a SQL statement, it is stored in a part of memory called the SQL buffer, and it remains there until you enter the next SQL statement. Sqlplus is an Oracle tool that recognizes and submits SQL statements to the Oracle server for execution, and it contains its own command language. The features of SQL can be used by a range of users, including those with little or no programming experience. It is a non-procedural language and reduces the amount of time required for creating and maintaining systems. It is an English-like language. The Sqlplus features: Sqlplus accepts ad hoc entry of statements. It accepts SQL input from files. It provides a line editor for modifying SQL statements and controls environmental settings. It formats query results into basic reports and accesses local and remote databases. Looking now at a comparison between SQL and Sqlplus. SQL is a language for communicating with the Oracle server to access data. It is based on the ANSI standard SQL, and it manipulates data and table definitions in the database. SQL is entered into the buffer on one or more lines. It does not have a continuation character and cannot be abbreviated. SQL uses a termination character to execute commands immediately, and it uses functions to perform some formatting. Sqlplus recognizes SQL statements and sends them to the server. It is an Oracle proprietary interface for executing SQL statements and does not allow the manipulation of values in the database. Sqlplus is entered one line at a time and is not stored in the SQL buffer. A dash can be used as a continuation character if the command is longer than one line. Sqlplus commands can be abbreviated and do not require termination characters. Commands are executed immediately, and Sqlplus uses commands to format data. The method used to invoke Sqlplus depends on the operating system you are running the Oracle database on. From a Linux environment, right-click on your Linux desktop and select Terminal. Enter the Sqlplus command as shown in the slide. Sqlplus, username, /password, and you can specify the name of the database you're connecting to. To ensure the integrity of your password, do not enter it at the operating system prompt. Enter Sqlplus and the username, and enter the password when prompted. Now that we have introduced you to Sqlplus, we're going to start looking at some of the Sqlplus commands. The first command. From within Sqlplus, you can use the describe command to display the structure of a table. The results displayed are the column names, the data type for the columns, and if these columns require data. The table name is the name of any existing table, view, or synonym that is accessible to the user. We are logged onto our Windows server, and we have our DOS window open. There are two methods for connecting to Sqlplus from a Windows server. The first one is through the DOS command line. The second is through the Sqlplus icon, which is configured during the installation of your Oracle software. To connect to Sqlplus, we're going to enter Sqlplus and our username. At the prompt, we will enter the password, and I will enter the name of the database that we are connecting to. We are now successfully logged on to our Sqlplus session. To describe a table, you can either enter the full word describe and the table name, and we'll end it off with a semicolon. When we press enter, the table definition is displayed. We see the column names, the data types for these columns, and whether these columns should contain data or not. The second option is to abbreviate describe with DESC. You then enter your table name, and the table definition is displayed. In this video, we introduced the Oracle tool Sqlplus. We described the differences between SQL and Sqlplus. We demonstrated how to log into a Sqlplus session and how to describe a table structure. In today's video, we are going to discuss and demonstrate the Sqlplus commands for editing SQL statements. Sqlplus commands are entered one line at a time and are not stored in the SQL buffer. These commands are: the first is the append. This adds text to the end of the current line. Change changes the old text to the new text in the current line. Change text deletes the text from the current line. Clear buffer. This deletes all lines from the SQL buffer. Delete deletes the current line. Delete with an N deletes the line number specified by N. And delete MN. This deletes all lines from M to N inclusive. Some guidelines when working with Sqlplus commands. Should you press enter before completing a Sqlplus command, the Sqlplus will prompt you with the line number. To terminate the SQL buffer, enter one of the terminator characters, either a semicolon or a slash. Or you can press enter twice and the SQL prompt will appear. Looking now at some additional Sqlplus editing commands. Input. This inserts an indefinite number of lines. Insert text. This inserts a line consisting of the text entered. List lists all the lines in the SQL buffer. List N lists one line as specified by the line number N. List MN lists a range of lines from M to N inclusive. Run displays and runs the current SQL statement in the buffer. N specified the line to make the current line. N text replaces line N with the text entered. And lastly, O text. This inserts a line before line 1 You can only enter one Sqlplus command for each Sql prompt. Sqlplus commands are not stored in the buffer. To continue a Sqlplus statement on the next line, end the first line with a hyphen. To demonstrate some of these editing commands, we will connect to our Sqlplus session. We will connect as the HR user. We will enter the HR password, and I will specify the database that I am connecting to. We are now successfully connected to our Sqlplus session. First, we're going to capture a SQL statement. So we're going to select star from HR departments. We are going to connect to our Sqlplus session. We will connect as the HR user. We will enter the HR password and the database connection that we are connecting to. At the SQL prompt, we will type a select statement. This will return the output of the SQL statement. The first command we're going to demonstrate is the list command. To list the last SQL statement, you can either type L or type the word list. This will show us the SQL statement. We are now going to change the table name that we select from. To do this, we will type C/the old table name, which is HR departments, and we'll type in the new table name and press enter. You can see at our prompt it shows the new SQL statement. If we do an L, it will show us our statement that's currently in the SQL buffer, and we can press R to run this statement. If we do list again, we list our SQL statement. We now want to delete all statements from the SQL buffer. So we type DEL to delete. We press enter, and if we then do a list, we will see that we have no lines in our SQL buffer. In today's lesson, we introduced and demonstrated the Sqlplus editing commands. In this video, we will look at the list, append, and change Sqlplus commands. The list command is used to display the contents of the SQL buffer. In the first example in the slide, the asterisk beside line 2 in the buffer indicates that line 2 is the current line. Any edits done on the SQL command line will be done to line 2. To edit a different line, enter the line number that you wish to edit, and the new current line will be displayed. To add text to the current line, use the append command. The newly edited lines are displayed. You can verify the contents of the buffer by using the list command. Many Sqlplus commands, including list and append, can be abbreviated to enter just their first letter. List can be abbreviated to an L and append abbreviated to an A. We use the change command to alter the contents of the current line in the SQL buffer. In the example in the slide, we replace the employees table with the departments table, and the new current line is displayed. We can then use the list command to verify the new contents of the buffer. To demonstrate the use of the list, append, and change commands, we are logged into Sqlplus as our HR user. First, we will select from the departments table. If we enter an L for list, the contents of the SQL buffer are displayed. The next change is we're going to append to our SQL statement. We will enter an A for append and then enter the statement we wish to append to our current statement. So we will add in department ID is equal to 10. We can see that in the SQL buffer that our SQL statement has been appended with the additional clause. If we execute the SQL statement now, only the records where the department ID equals 10 are returned. Lastly, we're going to change the name of the table that we're selecting from. We're now going to select from the employees table where department ID equals 10. This will show us only employees that are in department ID 10. To do this, at the SQL prompt, we enter a C for change. We enter the old table name, which is departments, and we enter the new table name. When we're done, we press enter. We can see in the SQL buffer that our SQL statement has been updated. We then execute our SQL statement, and we now retrieve employees in department 10. Now you know how to list, append, and change a SQL statement from the Sqlplus command line. SQL statements communicate with the Oracle server. Sqlplus commands control the environment, format query results, and manage files. When working with Sqlplus files, we can do the following. Save. The save command saves the current contents of the SQL buffer to a file. You can use the append command to add to an existing file, and you can use the replace command to overwrite an existing file. The default extension for these files is .sql. The get command writes the contents of a previously saved SQL file to the SQL buffer. The start command executes a previously saved command file. You can also use the @ sign to execute a previously saved command file. The edit command invokes the editor. In Unix, this would be VI, and in Windows, Notepad. If you use the edit command with a file name, the command allows you to edit the contents of a file. The spool command. The spool command stores query results in a file. When complete, enter spool off to close the spool file. The last command is exit. Exit is used to exit Sqlplus. We are now in our Sqlplus session. We will first create a SQL statement. We will select first name, last name from the HR employees table, and we'll execute this command. Should we wish to save this command, we simply type save, we give it a file name, and the output will be saved in a file. You can edit the contents of that script. So we say edit, and we give it the script name, and the contents will be opened in a Notepad file. We will make a small change to the script, so we will add in an order by clause to sort by the last name, and we will save our script. To then execute the script, we will use the @ sign. m_script.sql, and our script will be executed. If we use the get command and we specify our script name, it will load the contents of the script into the SQL buffer. The last command I'm going to show you is the spool command. We would like to spool the contents of our SQL statement to a file. So we enter spool, we give it a name, and we then execute our script. Once we are done, we can either say spool off, and this will close our file, or we can say exit. When we are finished working in our Sqlplus session, we exit, and this will close our Sqlplus session. Looking now in Windows Explorer, you will see we have two files. The first one is the script that we generated and saved. If I double-click on the script, it will be opened in Notepad for us to edit it further. The second file is the output. As you can see, this file contains the output of the script that was executed. In this video, we described and demonstrated the commands used when working with Sqlplus files. The Sqlplus commands we will cover in today's video are the save and start commands. The save command is used to store the current contents of the buffer in a file. You can save frequently used scripts for future use. To run a script in Sqlplus, you can use the start command. Alternatively, you can use the @ symbol to run a script. To demonstrate the save and start commands, we log into our Sqlplus session as the HR user. First, we will display the SQL command in the SQL buffer using the list command. Our SQL statement in the buffer is select star from employees where department ID equals 10. We now wish to save the SQL statement, as it is a query that we will need to run in future. To do this, at the Sqlplus command prompt, enter save and specify a file name. We will call our file dept10.sql and press enter. We can see that our file has been saved. Next, we're going to execute a Sqlplus script that was previously saved. To do this, enter start and the file name, mdept20.sql, and press enter. As my file is located in the same directory as the Sqlplus executable, I do not need to specify a directory. But should your file exist in a different directory, simply enter the path and the name of the file to be run. At the Sqlplus command prompt, you could use the @ instead of the start word to execute a Sqlplus script. We will execute the mdept10 script, and the output is returned to the screen. In this video, we covered the use of the save and start Sqlplus commands. In this video, we're going to learn how to use the Sqlplus server output command and look in more detail at the spool command. Most Pl SQL programs perform input and output through Sql statements to store data in database tables or to query those tables. All other Pl SQL input-output is done through APIs that interact with other programs. An example of this is DBMS output package, which has a procedure such as putLine. To see the results outside of Pl SQL requires another program, such as Sqlplus, to read and display the data passed to the DBMS output. The DBMS output line length limit has been increased from 255 to 32767 bytes. Sqlplus will not display the DBMS output data unless you first issue the command set server output on. Resources are not pre-allocated when setting server output on. With the server output command, you can specify the size. Size sets the number of bytes of the output that can be buffered within the Oracle database server. The default is unlimited, and when it is set, cannot be less than 2,000 or greater than 1 million. Unless you want to conserve memory, you can use unlimited. With the server output command, there is no performance penalty. Additional information about server output command can be found in the Oracle Database Pl SQL Users Guide and the Reference 12c Guide. The spool command stores query results in a file or optionally sends the file to a printer. The spool command has now been enhanced as you can now append and replace an existing file. Previously, you could only use the spool command to create or replace a file. The spool command options are the following. File name. This spools the output to the specified file name. Create creates a new file with the specified name. Replace replaces the contents of an existing file. If the file does not exist, replace will create the file. Replace is the default. Append. This option adds the contents of the buffer to the end of the file that you specify. Off stops pooling. Out stops pooling and sends the file to your computer's default printer. To spool the output generated by commands in a script and without displaying the output on screen, use the command set term out off. This command does not affect the output from commands that are run interactively. Quotation marks must be used around the file names that contain white spaces. To create a valid HTML file using spool append commands, you must use the prompt command to create HTML page headers and footers. The spool append command does not pass HTML tags. In this video, we discussed the Sqlplus server output command and looked in more detail at the spool command. In this video, we are going to look at how to use the Autotrace command within our Sqlplus session. The Autotrace command displays a report after the successful execution of Sql DML statements, such as select, insert, update, or delete. The report can now include execution statistics and the query execution path. In the slide, we show all the options for enabling Autotrace. Depending on the option selected, we can limit the information returned by the Autotrace command. To set Autotrace on and to include all trace, explain plan, and statistics information, the syntax is set Autotrace on. To make use of Autotrace, ensure that the user has been granted plus trace privilege. In our demonstration, we make use of the HR user and have granted plus trace to the HR user to allow us to use the Autotrace command. For this demonstration, we have logged into our Sqlplus session as the HR user. We can show which user we are connected as by typing show user at the command prompt, and this will show the user we're connected as. Our user has been granted the plus trace privilege. Before running our SQL statement, we first enable Autotrace. To do this, we enter set Autotrace on. We then enter our SQL statement. We are going to select star from departments, where department ID is equal to 10, and we press enter. The output returned is the following. First, the results of the query are returned. Next, the explain plan for the SQL statement is displayed. And lastly, we have the statistics for the SQL statement. In this video, we introduced you to the Sqlplus Autotrace command. We discussed the privileges required to use Autotrace and demonstrated how to use the Autotrace command in Sqlplus. Retrieving data using the SQL select statement. In its simplest form, a select statement must include a select clause, which specifies the columns to be displayed, and a from clause, which identifies the table containing the columns that are listed in the select clause. Looking now at the syntax in the slide, within the select, the star represents all columns. Distinct suppresses duplicate records. The named column, you can specify specific column names. Alias, an alias is used to give a different heading name to selected columns. The from table specifies the name of the table containing the column names. Words used throughout this learning path are the following. Keyword. A keyword refers to an individual SQL element. Examples are select and from. These are keywords. A clause. This is part of a SQL statement. For example, select employee ID, last name, etc. A statement is a combination of two or more clauses. For example, select star from employees. To display all columns of data in a table, follow the select keyword with an asterisk. In the slide, we can see the departments table has 4 columns: department ID, department name, manager ID, and location ID. You can also display all columns in the table by listing them after the select keyword. In Sql Developer, you can enter your SQL statement in the Sql Worksheet window. Click on the Execute Statement icon to execute the statement. The output is displayed in the Results tab below. The select statement can be used to display specific columns of the table by specifying the column names separated by commas. The example in the slide displays all the department numbers and location numbers from the departments table. In the select clause, specify the columns that you want in the order in which you want them to appear in the output. We are logged into our Sqlplus session. First, we're going to select all columns from the departments table. So we will type select star from departments and enter. This will return all the columns for the table, and they are displayed in the sequence of the columns in the table. Next, we will select 2 columns from the departments table, and we will order the columns in the order that we want it to appear in the output. Select location ID and department ID from departments. When we execute the statement, you can see that the location ID is the first column and the department ID is second. In the last example, we will demonstrate how to select the distinct department IDs from the employees table, and we will give the column name an alias. The query will look as follows. select distinct department ID. The alias we will give the column, department, from employees, and we will order it by, so we will sort it by department ID. We now execute our statement, and the result that is returned is a distinct list of department IDs that exist in the employees table, and we have sorted it by department ID number. In this lesson, we described the SQL select statement, and we demonstrated how to select data from tables. Writing SQL statements. You can write valid SQL statements that are both easy to read and edit by using the following simple rules and guidelines. SQL statements are not case sensitive. SQL statements can be entered on one or more lines. Keywords cannot be abbreviated or split across lines. Clauses are usually placed on separate lines. Indents are used to enhance readability. In Sql Developer, SQL statements can be optionally terminated by a semicolon and are required when you execute multiple SQL statements. In Sqlplus, you're required to end each SQL statement with a semicolon. Keywords are typically entered in uppercase. All other words such as table names and column names are entered in lowercase. To execute a SQL statement, in Sql Developer, click on the Run Script icon or press F5 to run all the commands in the Sql worksheet. You can also click on the Execute Statement icon or press F9. This will execute the statement at the cursor. In Sqlplus, terminate the SQL statement with a semicolon and then press Enter to run the command. In Sql Developer, the column headings are displayed in uppercase and are left aligned. The column headings displayed can be overridden by using an alias. In Sqlplus, character and date column headings are left aligned, number column headings are right aligned, and the default heading displayed is in uppercase. We are connected to our Sqlplus session as the HR user, and we will demonstrate a simple and easy-to-read SQL statement. The keyword select will be entered in capital letters. We will then specify the columns that we want to select from. We will enter last name, hire date, and salary, and then we'll press Enter. On the next line, we will enter the From keyword, and the table that we're selecting from is the Employees table. When we are done, we end our statement off with a semicolon, and we execute our SQL statement. After executing our SQL statement, we can see the data is returned, and you will see that the column names are in uppercase. We will now demonstrate the same SQL statement in Sql Developer. We have connected to our HR connection and entered the SQL statement in the SQL Statement window. There are two methods by which we can execute this statement. The first is to place the cursor on the line of the statement which we wish to execute and then click on the Execute Statement icon. The output will be displayed in the Query Result window below. The second option is to run all statements in the Sql Worksheet window. To do this, we click on the Run Script icon. The Run Script icon will also display the output in the Script Output window below. You have now learned the guidelines for writing a SQL statement, and we have demonstrated a basic select statement in both Sqlplus and Sql Developer. Working with arithmetic expressions in a select statement, you may need to modify the way in which data is displayed, or you may want to perform calculations or look at what-if scenarios. All these are possible using arithmetic expressions. An arithmetic expression can contain column names, constant numeric values, and the arithmetic operators. This slide lists the arithmetic operators that are available in SQL. These are add, subtract, multiply, and divide. You can use arithmetic operators in any clause of a SQL statement except the from clause. With the date and timestamp data types, you can use the addition and subtraction operators only. The example in the slide uses the addition operator to calculate a salary increase of $300 for all employees and shows the salary plus $300 in the output. Note that the resultant calculated column, salary plus $300, is not a new column in the employees table. It is for display only. By default, the name of the column comes from the calculation that it generated. In this case, it would be salary plus $300. The Oracle survey ignores blank spaces before and after the arithmetic operator. Looking now at the rules of precedence when using arithmetic operators. Multiplication and division occur before addition and subtraction. Operators of the same priority are evaluated from left to right, and parentheses are used to override the default precedence or to clarify the statements. To demonstrate using arithmetic expressions in a SQL statement, we are connected to our HR connection in Sql Developer. In our first SQL statement, we would like to see the employee's salary value if each employee received a $300 increase. Our select statement will look as follows. We will select last name, salary, and for our arithmetic expression, we will select salary plus $300 from the employees table. We will execute our SQL statement. The output in the query results window lists each employee's last name, their current salary, and the value that their salary would be if they each received a $300 increase. In our second example, we would like to show the value should each employee receive a 10% increase. To do this, our SQL statement will look as follows. We will select last name, salary, and for our arithmetic expression, we will enter salary times 0.1 from employees. We execute this SQL statement. The output in the query results window shows the last name, the employee's current salary, and the value that they would receive should they receive a 10% increase. In this video, we introduced arithmetic expressions in SQL and demonstrated how to use arithmetic expressions in a SQL statement. When using arithmetic expressions in a SQL statement, there is a standard order of precedence for the arithmetic expressions. Multiplication and division are performed before addition and subtraction expressions. In the first example in the slide, we display the last name, salary, and annual compensation of the employees. The annual compensation is calculated by multiplying the monthly salary by 12 and adding a one-time bonus of $100. Note that the multiplication is performed before the addition. To reinforce the use of the standard order of precedence and to improve clarity, we can use parentheses. We can, in addition, use parentheses to override the rules of precedence in order to specify the desired order in which operators are to be executed. In the second example in the slide, we display last name, salary, and the annual compensation of the employees. The annual compensation is calculated by adding a monthly bonus of $100 to the monthly salary and then multiplying that subtotal by 12. Because of the parentheses, addition takes priority over multiplication. To demonstrate the arithmetic order of precedence, we are now in our Sql Developer session and we are connected to our HR connection. In the Sql Worksheet area, we enter our SQL statement. We will select last name, salary, and our arithmetic expression, which is 12 times salary plus 100, and we select from the employees table. When we are done, we execute our SQL statement. In the query result window, we see our columns, last name, salary, and the annual compensation, which is broken down into 12 times the salary plus $100. In the second example, we will use the parentheses to override the rules of precedence. Our SQL statement, we will select last name, salary, and for our arithmetic expression, we will use 12 times and then in brackets salary plus $200 from employees. When we're done, we execute our SQL statement. In the query result window, we see our last name, salary, and our arithmetic expression. The arithmetic order is as follows. First, we add the salary plus $200 and then multiply the result by 12. In this video, we covered the order of precedence when using arithmetic expressions. When a row lacks a data value for a particular column, that value is said to be null or to contain a null. A null is a value that is unavailable, unassigned, unknown, or inapplicable. A null is not the same as a zero or blank space. Columns with null values can be selected in a select query and can be part of an arithmetic expression. Any arithmetic expression using null values results into a null. Columns of any data type can contain nulls, however, there are some constraints. The not null and primary key constraint prevent nulls from being used in the column. In the example in the slide, notice that only a sales manager or sales representative can earn a commission in the commission percent column of the employees table. Other employees are not entitled to earn commission. A null represents that fact. By default, SQL Developer uses the literal word null to identify null values. To set it to something more relevant for yourself, within SQL Developer, from Tools menu, go to Preferences, expand the database node, click on Advanced Parameters. On the right-hand side, enter the appropriate value in the Display Null Value As field. Any column value in an arithmetic expression containing a null value will result in a null. For example, should you attempt to perform division by 0, you get an error. However, if you divide a number by a null, the result is null or unknown. In the example in the slide, employee King does not receive any commission. This is because the commission percent column in the arithmetic expression is null, and therefore the result is null. We are in SQL Developer and connected to our HR connection. To demonstrate null values in a table, we're going to show you two examples. In the first, we're going to select all records from the employees table. We execute our SQL statement. In the query result window, we can see the data where there are null values. An example, the commission percent column. This shows that these employees are not entitled to earn a commission. To change the literal, identifying the null values, in SQL Developer, we go to Tools, click on Preferences, and within Preferences, under Database, we select Advanced. On the right-hand side, we will update the Display Null Value column. For our example, we will use Empty to show all records where there are null values, and we click on OK. If we execute our SQL statement again, you will see that in the query result window, the commission percent column has changed to empty. This means that these are null values. In our next example, we will demonstrate null values in an arithmetic expression. Our select statement, we're going to select the employee ID, the last name for the employee, their job ID, the commission percent column. We will then do an arithmetic expression, salary plus commission percent, and give it an alias, salary and commission. We are selecting from the employees table, and for this example, we're only going to select two employee IDs, employee ID 100 and 150. We execute our SQL statement. In the query result output, we can see where we had a commission percent of null, the arithmetic expression is also null. For employee 150, who had a value in commission percent, there is a resultant value in our arithmetic expression. You have now learned about defining a null value and how null values are evaluated in an arithmetic expression. When working with SQL statements, we can define aliases for our column headings. When we display the results of a query, the name of the selected column is normally used as the column heading. This heading may not be descriptive and may therefore be difficult to understand. You can change a column heading by using a column alias. A column alias renames a column heading. It is useful for calculations. By default, a column alias heading appears in uppercase. A column alias immediately followed by the column name. You can optionally use the as keyword between the column name and the alias. The column alias requires double quotation marks if it contains spaces or special characters such as a hyphen, underscore, or if it is case sensitive. The examples in the slide display the names and commission percentages of all employees. Note, the optional as keyword has been used before the alias column name. The result of the query is the same whether the as keyword is used or not. Also note that the SQL statement has the column aliases in lowercase, whereas the result query displays the column headings in uppercase. Uppercase is the default for alias column headings. In the second example, we display the last name and annual salaries of all employees. Because the alias column heading contains a space, it has been enclosed in double quotation marks. Note, in the query result, the heading is displayed exactly the same as the column alias is defined. To demonstrate the use of column aliases within a SQL statement, we are in Sql Developer and connected to our HR connection. In our first example, we select from the employees table. We select last name. We use the keyword as. We give it an alias name. We then select commission percent and we give it the alias commission from employees. We execute our SQL statement. In the query result window, the column headings are displayed as the aliases are specified in the SQL statement, and by default they are displayed in uppercase. Note, the as keyword is optional when defining a column alias. In our second example, we will use the same query, but this time we will put our column aliases in double quotes and use a space in one of the aliases. We select last name, we'll put name in double quotes, commission percent, and we've extended it to commission space percent. We execute our SQL statement. In our query result window, we can see that our column headings are now displayed exactly as they were specified in the SQL statement. This is due to us using double quotes around our aliases. You now know how to use a column alias to give columns a more meaningful name in a SQL statement. Concatenation operators can be used in SQL statements to link columns to other columns, to arithmetic expressions, or to constant values. A concatenation operator is represented by two vertical bars, and a character expression is the resultant column. The example in the slide concatenates the last name and job ID columns and gives an alias employees. These two columns are combined to make a single output column. The as keyword before the alias name makes the select clause easier to read. Should you concatenate a null value with a character string, the result is the character string. We are in Sql Developer and connected to our HR connection. To demonstrate the concatenation operator, we will enter the following statement. We will select first name, our concatenation operator, and we will enter the last name. We will then use an alias, and we will call the alias employee name. We will enter two additional columns that we wish to select, the job ID and the department ID. And we will select from the employees table. When we are ready, we execute our SQL statement. We combine the first name and the last name columns into a single character expression. We then added an alias, employee name. We in addition selected some additional columns, the job ID and department ID for the employee. In the SQL output window, we can see the alias column name as the heading for our character expression column, and the data consists of the employee first name and last name. And we also see our additional columns, job ID and department ID. In this video, we introduced the concatenation operator and demonstrated how to use the concatenation operator. In this video, we're going to look at how we use literal character strings in a SQL statement. A literal is a character, number, or date that is included in the select list. It is not a column name or column alias and is printed for each row returned. Literal strings of free-formatted text can be included in the query result and are treated the same as a column in the select list. Date and character literals must be enclosed within single quotation marks. Number literals do not need to be enclosed in the same manner. Each character string is output once for each row returned. In the example in the slide, the SQL select statement displays the last name and job code columns for all employees. It includes the literal is a to form a sentence in the query output. The column has a heading, employee details, and the spaces between the single quotation marks improve the readability of the output. To demonstrate the use of literal character strings, we have our Sql Developer session open and we are connected to our HR connection. The SQL statement that we will use in our example is, we will select the last name of each employee. We will then concatenate it with our literal character string. So we will use the concatenation operator and then we'll enter our character string. We will enter : 1 month salary. We will end off our character string with a single quotation mark. And we will then concatenate that with the salary column. We will give our character string a heading. We will call it monthly salary. And we are selecting from the employees table. We execute our SQL statement. In this SQL statement, we made use of the concatenation operators to link two columns and to create a character expression. The column heading is monthly salary and is based on the alias defined in the SQL statement. The data returned are the employee's last name, our literal string value, and the monthly salary that each employee receives. One row is returned for each employee in the employees table. You are now ready to write your SQL statement using literal character strings. Many SQL statements use character literals in expressions and conditions. Should the literal itself contain a single quotation mark, you can use the quote or the Q operator and select your own quotation mark delimiter. You can choose any convenient delimiter, a single byte or multi-byte, or any of the following pairs: a curly bracket, a square bracket, a round bracket, or the less than and greater to sign. The Q operator increases readability and usability. The example in the slide shows the string contains a single quotation mark, which is normally interpreted as a delimiter of a character string. By using the Q operator, brackets are used as the quotation mark delimiters. The string between the bracket delimiters is interpreted as a literal character string. We will now demonstrate how to use the alternative quote operator. We have our Sql Developer session open and we are connected to our HR connection. In our example, we need to include a single quotation mark in the character string. Our Sql statement looks as follows. We select department name. We specify the concatenation operator. This links the department name to the character string. We will then use a square bracket as our quote operator. We specify our character string. We then use another concatenation operator. This is to link the character string to the manager ID. We include an alias, departments, and manager. We execute our Sql statement. And in our query result window, we can see our column heading, departments and manager, and the output, we see our department name, our character string, department's manager ID is, and the manager ID. You now know how to use the Q operator in a Sql statement to select your own quotation mark delimiter. Duplicate rows are displayed by default in a query. Unless otherwise specified, Sql displays the results of a query without eliminating duplicate rows. In the first example in the slide, the query displays all department numbers in the employees table. There are multiple employees in the same department, and therefore the department numbers are repeated. To eliminate duplicate rows in the result set, we include the distinct keyword in the select clause immediately after the select keyword. In the second example in the slide, the employees table contains 20 rows, but there are only 7 unique department numbers in the employees table. The distinct keyword affects all the selected columns, and the result is every distinct combination of the columns is returned. To demonstrate the use of the distinct keyword, we are logged into our HR connection in Sql Developer. In our first example, we demonstrate multiple job IDs in the employees table. Our Sql statement is select job ID from employees. We then execute our Sql statement, and in the query result, we can see we have multiple job IDs. In our next query, we will make use of the distinct keyword to display a distinct list of job IDs in the employees table. Our Sql statement will look as follows. We will select distinct job ID from employees. We execute our Sql statement. We can now see in our query result window, we have 19 rows that are returned. There are 19 distinct job IDs within the employees table. In this lesson, we demonstrated how to eliminate duplicate rows from a Sql statement using the distinct keyword. The describe command is used to display the structure of a table. The command displays the columns, data types, and shows whether a column must contain data. That is, whether the column has a not null constraint. In the syntax, table name is the name of any existing table, view, or synonym that is accessible to the user. Describe is a Sqlplus command and is supported by Sql Developer. It is abbreviated as DESC. Using the Sql Developer GUI interface, you can select the table in the connections tree and use the Columns tab to view the table structure. The example in the slide displays information about the structure of the employees table using the describe command. In the table description, the null column indicates that the values for this column may be known or unknown. Not null indicates that a column must contain data. The type column displays the data type for a column. We are first going to demonstrate the describe command in Sqlplus. We are logged into Sqlplus as the HR user. To describe the employees table, we type desk for describe and the table name. The description of the table is displayed. We can see the column names, the null column, which indicates whether a column must contain data or not, and the data type per column. We will now demonstrate how to use the describe command in Sql Developer. The describe command is supported by Sql Developer. We are connected to our HR connection, and in our Sql Worksheet window, we enter our command, desk for describe, and we will describe the departments table. We execute this command, and in the script output window below, we can see the definition of the table. The second option for viewing the table structure in Sql Developer, we go to the connections tree, we click on our HR connection, we open our tables tab, and we select the table for which we wish to view the structure. On the right-hand side of the screen, in the columns tab, we will see our table definition. You now know how to describe a table structure in both Sqlplus and Sql Developer. Now that you've learned the basics of working with Sqlplus and the basics of the Sql select statement, it's time to put that knowledge to work. In this exercise, you will spool the output of a Sql statement to a file in Sqlplus. You will write a Sql select statement incorporating an arithmetic expression including operator precedence, a column alias, a concatenation operator, and a literal character string. You will then write a Sql statement eliminating duplicate rows for the department ID in the employees table. When you are ready, pause this video, perform the exercise. When you are done, come back to the video and I will work through the exercise with you. There are various methods for performing these exercises, and the method I will demonstrate is just one of these methods. We are connected to our Sqlplus session, and in the first task we will spool the output of a Sql statement to a file. At the command prompt, type spool and the name and path where the file will be located. We will enter C:\scripts and we will call our file spool_exercise.txt. We press enter and we are now spooling all the contents of our Sqlplus session. We will execute a Sql statement. And once we are done, you can either exit your Sqlplus session to end spooling, or you simply type spool off. In Windows Explorer, we locate our file in the directory C:\scripts. We open our file. We can see that all commands and query results from our Sqlplus session have been spooled to the text file. Next, we're going to write a Sql statement that will incorporate an arithmetic expression, a column alias, the concatenation operator, and literal character strings. Our Sql statement will look as follows. We will select, and first we'll specify a character string in single quotes. We will then concatenate that character string with the first name column. We will concatenate that with a space in single quotes. We will then add the concatenation operator for our last name column. And we then concatenate that with a text string, earns an annual salary of. We close our character string, and now we're going to concatenate it with an arithmetic expression. We're going to calculate the salary for 12 months. We will give that a column alias. We will call it annual salary. And we are selecting from our employees table. We execute our Sql statement. In the query result window, we can see our column alias as our heading, and in the query result, we can see the character strings we defined, our columns, the first name, last name, and our arithmetic expression where we calculated the annual salary for the employee. Each row displays the name of the employee and their annual salary. To demonstrate the use of an arithmetic expression, including operator precedence, we have the following SQL statement. We select last name, salary. We will then create an arithmetic expression, 12 times salary plus $250. We'll give this a column alias, annual plus bonus. We will then add in a second arithmetic expression. This time we will have salary plus $250 times 12. The alias for this column will be annual after increase. We select from our employees table and we execute our SQL statement. In the query result window, the first column, annual plus bonus, demonstrates the multiplication is performed before the addition. This demonstrates the order of precedence. In the annual after increase column, we use parentheses to override the order of precedence. The arithmetic expression for this column reads, add $250 to the monthly salary and then multiply it by 12 months. To demonstrate how to eliminate duplicate rows in the employees table for the department ID column, our select statement is as follows. Select distinct department ID from employees. We execute this SQL statement. And in the query result window, we show a distinct list of department IDs in the employees table. To limit the rows returned by a SQL statement, we use the where clause. In the example in the slide, assume you want to display all the employees in Department 90. The rows with a value of 90 in the Department ID column are the only ones that are returned. This method of restriction is the basis of the where clause in SQL. You can restrict the rows that are returned from the query by using the where clause. A where clause contains a condition that must be met, and it directly follows the from clause. If the condition is true, the row meeting the condition is returned. The syntax of the where clause consists of the where keyword. This restricts the query to rows that meet a condition. A logical expression. A logical expression is composed of column names, constants, and a comparison operator. It specifies a combination of one or more expressions and Boolean operators and returns a value of true, false, or known. The where clause can compare values in columns, literal, arithmetic expressions, or functions, and it consists of 3 elements: a column name, a comparison condition, and a column name, constant, or list of values. In the example, the select statement retrieves the employee ID, last name, job ID, and department number of all employees who are in Department 90. Note, you cannot use a column alias in the where clause. We are connected to our HR connection in Sql Developer. The first query we're going to run is a select star from the employees table. We are selecting all records from the employees table. We execute our SQL statement, and in the query result, you can see all records that exist in the employees table. We would now like to limit this SQL statement to returning only employees that report to Manager ID 103. To do this, we go back and we edit our SQL statement. We are going to select all columns from the employees table, and we will now add in a where clause. We're going to specify where manager ID is equal to 103. We then execute our SQL statement, and we can now see that our query result has returned only 4 rows. These 4 rows are the 4 employees that report to manager 103. In this lesson, we introduced you to the where clause in a SQL statement and demonstrated how to use the where clause to limit the rows returned by a SQL statement. In this video, we're going to look at how to use character strings and dates in a where clause within a SQL statement. Character strings and dates in the where clause must be enclosed in single quotation marks. Number constants do not need to be enclosed. All character searches are case sensitive and date values are format sensitive. In the example in the slide, if the last name was entered in uppercase, no rows would be returned by the SQL statement, as the table stores the last name in mixed case. The Oracle database stores dates in an internal numeric format, represented by century, year, month, day, hours, minutes, and seconds. The default date display is in the DD-MON-RR format. The RR date format and how to change the default date format will be covered in future videos in this learning path. You will also learn about the use of single row functions such as upper and lower to override case sensitivity. In Sql Developer, we are connected to our HR connection, and we will demonstrate a character string and a date when used in a where clause in a SQL statement. In our first SQL statement, we are going to select records for employees with the surname of Austin. Our query will look as follows. We will select last name, job ID, and department ID. These are the columns that we wish to view. From employees, where the last name is equal to Austin. We execute our SQL statement. In the query result window below, we can see the rows returned where it matches the surname Austin. Note that the characters are case sensitive, so it would not return any other rows if it did not match this case. For our second SQL statement, we're going to select records for all employees with a hire date of 20 August 05. Our SQL statement is going to look as follows. We will select the first name, last name, hire date, and salary from employees where the hire date is equal to 20 August 05. We execute our SQL statement. In the query result window, we can see that there are 2 rows returned, and these are the employees that were hired on the 20th of August 05. Our next SQL statement that we will demonstrate, we will select records for all employees who earn a salary of $4,800. Our query will look as follows. We will select the employee ID, their first name, last name, and their salary from the employees table where the salary is equal to $4,800. We execute our SQL statement. In the query result window below, we can see the rows that are returned for the employees that earn a salary of $4,800. This SQL statement demonstrated that number constants do not need to be enclosed in single quotation marks. We did, however, for the date and character strings, so here was our date string and our character string, we had to enclose them in single quotation marks. In this video, we covered the use of character strings and dates and number constants in a where clause within a SQL statement. Comparison operators are used in conditions that compare one expression with another value or expression. The comparison operators used in a where clause are equal to, greater than or equal to, less than or equal to, not equal to, between two values, in matches any list of values, like matches a character pattern, is null, is a null value. Aliases cannot be used in the where clause. In the example in the slide, the select statement retrieves the last name and salary from the employees table for any employee whose salary is less than or equal to $3,000. In the where clause, we have an explicit value supplied. This explicit value of 3,000 is compared to the salary value in the salary column of the employees table. To demonstrate the use of comparison operators in the where clause of a SQL statement, we are logged into our HR connection in Sql Developer. Our first SQL statement will look as follows. We will select last name, hire date, and salary from the employees table where the salary is greater than or equal to 17,000. We execute our SQL statement. In the query result window, we can see there are 3 rows returned. These are the 3 employees whose salary is greater than or equal to 17,000. In our second SQL statement, we're going to select last name, hire date, department ID, and salary from the employees table where the department ID is not equal to 50. So we would like to see a list of all employees who are not in department 50. We execute our SQL statement. And in the query result window, we have a list of all employees that are not in department 50. In this video, we introduce the comparison operators used to compare one expression with another value or expression in a where clause in a SQL statement. In this video, we will learn about range conditions when using the between and in operators in the where clause in a SQL statement. We limit the rows selected in a SQL statement using the where clause. We can display rows based on a range of values using the between operator. The range specified contains a lower and upper limit. The select statement in the slide returns rows from the employees table for any employee whose salary is between $2,500 and $3,500. The values specified with the between operator are inclusive. The lower limit, however, must be specified first. The between operator can also be used on character values. The next operator used in the where clause that we will learn about is the in operator. The in operator is used to test for values in a specified set of values. The condition defined using the in operator is also known as the membership condition. The example in the slide displays employee numbers, last names, salaries, and the manager's employee number for all employees whose manager employee number is 100, 101, or 201. The set of values can be specified in any random order. The in operator can be used with any data type. For example, we could select records from the employees table where the last name is in the list of specified last names. If characters or dates are used in a list, each value should be enclosed within single quotation marks. To demonstrate the use of the between and in operators in a SQL statement, we are logged into our HR connection in Sql Developer. In our first SQL statement, we're going to demonstrate the between operator. We will select all columns from the employees table where hire date is between the 7th of June 2002 and 31 December 2002. We execute our SQL statement. The rows returned in the query result window below are only a list of employees who have a hire date between the 7th of June and the 31st of December. Values specified in the between operator are inclusive. We've now demonstrated the between operator. Next, we're going to demonstrate the in operator. Our select statement will look as follows. From the employees table, where last name in. So we're going to specify a list of last names that we would like to query in the employees table. These last names are King, Chen, and Gi. Note, these are character data types, therefore they should be in single quotation marks, and they are case sensitive. We execute our SQL statement. In the query result window, only employees with last names in the in list are returned. You now know how to use the between and in operators in the where clause of a SQL statement. In this video, we will learn about the like operator used in the where clause for pattern matching. You may not always know the exact value to search for, and you can now select rows that match a character pattern by using the like operator. The character pattern matching operation is referred to as a wildcard search, and search conditions can contain either literal characters or numbers. Two symbols can be used to construct the search string. The % symbol represents any sequence of 0 or more characters. The underscore represents a single character. In the example, the select statement returns the first name from the employees table for any employee whose name begins with the capital letter S. Note, it is an uppercase S, and therefore rows with the lowercase s are not being returned. The like operator can be used as a shortcut for some between comparisons. The wildcard characters % and underscore can be used in any combination with literal characters for pattern matching. The example in the slide displays the names of all employees whose last names have the letter O as the second character. When you need to have an exact match for the actual percentage and underscore characters, use the escape identifier. To demonstrate the use of the like operator in the where clause of a SQL statement and the use of wildcard characters, we are logged into our HR connection in Sql Developer. In our first SQL statement, we're going to select first name from employees, where first name like capital D, %, close our single quotes, and then we execute our SQL statement. The query result shows the first name for all employees whose first names start with a capital D. The result is case sensitive and would not return any rows where the first name starts with a lowercase d. In addition, we use the % symbol, which represents 0 or more characters following the capital letter D. In our next SQL statement, we will use the underscore to demonstrate the search, where we combine both wildcard characters in the search condition. We are going to select star from departments, where department name, like, the first character will be a wildcard character, the second character will be a capital T, and we will end it off with a %, so the remaining letters will be wildcard characters. We execute our SQL statement. In the query result window, the rows returned are all department names where the second letter contains a capital T. In this video, we covered the use of the like operator in the where clause within a SQL statement and demonstrated the use of wildcard characters within search conditions. In this video, we're going to learn how to test for null conditions in the where clause of a SQL statement. The null conditions include the is null condition and the is not null condition. The is null condition tests for nulls. A null means that the value is unavailable, unassigned, unknown, or inapplicable. You cannot test with the equal to sign. A null cannot be equal or unequal to any value. The example in the slide retrieves the last name and manager ID of all employees who do not have a manager. Another example would be to display the last name, job ID, and commission % for all employees who are entitled to receive a commission. The query would be select last name, job ID, and commission % from employees where commission % is not null. We are logged into our HR connection in Sql Developer, and we will demonstrate testing for null conditions in the where clause of our SQL statements. In the first SQL statement, we will select from the employees table where the commission % is null to identify all employees who are not eligible to receive a commission. Our SQL statement will look as follows. We will select last name, job ID, and commission % from the employees table where commission % is null. We execute our SQL statement. In the query result window, the rows returned are only those where the commission % is null, meaning these employees are not eligible to receive a commission. In our second SQL statement, we're going to use the same SQL statement, but this time we're going to select where the commission % is not null. We would like to see a list of all employees who receive a commission. We update our SQL statement to include not in the syntax. We execute our SQL statement. Now in the query result window, we can see a list of only the employees who receive a commission. And that is how we use the is null and is not null operators to test for nulls in the where clause of a SQL statement. A logical condition combines the results of two or more component conditions to produce a single result based on those conditions, or it inverts the result of a single condition. A row is returned only if the overall result set of the condition is true. Three logical operators are available in SQL. The first is AND. AND returns true if both component conditions are true, or returns true if either component conditions are true. Not returns true if the condition is false. All examples so far have specified only one condition in the where clause. We can use several conditions in a single where clause using the and or operators. The AND operator requires both the component conditions to be true. In the example in the slide, both conditions must be true for any record to be selected. Only those employees who have a job title that contains the string man and earn a salary of $10,000 or more are selected. All character searches are case sensitive and must be enclosed in single quotation marks. No rows would be returned if man was not specified in uppercase. The AND truth table shows the results of combining two expressions with the AND operator. For example, if both conditions are true, then the result evaluates to true. But if one condition is true and one condition is false, then the result evaluates to false. Should one condition evaluate to true and one is null, then the result is null. The OR operator requires either component condition to be true. In the example in the slide, either component can be true for any record to be selected. Any employee who has a job ID that contains the string man, or any employee who earns $10,000 or contains both conditions is selected. The OR truth table shows the results of combining two expressions with the OR operator. For example, if both conditions are true, then the result evaluates to true. If one condition is true and one condition is false, then the result evaluates to true. Should one condition evaluate to true and one condition evaluate to null, the result is then true. The NOT operator returns records where the record is not listed in the condition. For example, in the slide, the last name and job ID are returned for all employees who do not have a job ID of IT programmer, ST clerk, or SA rep. The NOT truth table shows the results of applying the NOT operator to a condition. To demonstrate the use of conditions by using the logical operators AND, OR, and NOT, we are in Sql Developer and logged into our HR connection. In the first Sql statement, we will demonstrate the AND operator. We will select all employees who are in Department 60 and who earn a salary of less than $5,000. Our Sql statement will look as follows. Select all columns from employees where department ID is equal to 60 and salary less than 5,000. We execute our Sql statement. In the query result window, the rows returned are the employees who have a department ID of 60 and whose salary is less than 5,000. When both these conditions evaluate to true, the row is returned by the query. In our next Sql statement, we will demonstrate the OR operator. We will select all employees where the manager ID is null or where the employee receives a salary of less than $2,500. Our Sql statement will look as follows. We will select all columns from the employees table where manager ID is null or salary is less than $2,500. We execute our Sql statement. In the query result window, the first record shows the manager ID is null, even though his salary is greater than $2,500. Using the OR operator, where either of the conditions results in true, the row is returned. The same for the remaining rows. The manager ID is not null for these, but the employee's salary is less than $2,500. One of the conditions is evaluated to true, and therefore these rows are returned. In our last SQL statement, we are going to demonstrate the use of the NOT operator. We will select all employees who are not in a list of defined departments. Our SQL statement will look as follows. We will select all columns from employees where department ID not in, and we will list our departments 50, 60, 80, 90, and 100. We will execute our SQL statement. The output in the query result window shows a list of all employees who do not have a department ID in the list specified in the SQL statement. Where a row evaluates to not true, for example, the department ID is not in the list, the row is returned. And where the row evaluates to not false, for example, the department ID is in the list, the row is not returned. In this video, we have covered the use of the logical operators and, or, and not to define conditions in a where clause in a SQL statement. The rules of precedence determine the order in which expressions are evaluated and calculated. The table in the slide lists the default order of precedence. The default order can be overridden using parentheses around the expressions that you want to calculate first. The order is: arithmetic expressions are evaluated first, then the concatenation operator. After the concatenation operator, the comparison conditions are evaluated. Next, the is, not null, like, and not in operators are evaluated. Then it is the between and not between operators. After the between operators, the not equal to is evaluated. Then the not logical operator. After that, the and operator. And lastly, the or operator. The example in the slide demonstrates the precedence of the and operator. In this example, there are two conditions. The first condition is that the department ID is 80 and the salary is greater than $10,000. The second condition is where the department ID is equal to 60. The select statement therefore reads as follows. Select the row if an employee's department ID is 80 and they earn more than $10,000, or if the employee's department ID is 60. In this example, we demonstrate the use of parentheses. In the SQL statement, there are two conditions. The first condition is that the department ID is equal to 60 or 80. The second condition is that the salary is greater than $10,000. The statement reads as follows. Select the row if an employee's department ID is either 60 or 80 and if the employee earns more than $10,000. To demonstrate the rules of precedence, we are logged into our HR connection in Sql Developer. In our first SQL statement, we will have two conditions. The first is where the manager ID is equal to 120 and the department ID is equal to 50. The second condition is or where the manager ID is equal to 100. Our select statement will look as follows. We will select all columns from the employees table where manager ID is equal to 100 or the manager ID is equal to 120 and the department ID is equal to 50. We execute our SQL statement. There are 22 rows returned. The reason for this is where it's department ID 50 and manager ID 120, we return all the rows where manager ID is 120 and department ID is 50. For the second condition, we then return all rows where the manager ID is 100. In our second SQL statement, we will demonstrate the use of parentheses. We will use the same query. The only difference this time is we will put our manager ID equal to 100 or manager ID equal to 120 in brackets. We are now evaluating where the manager ID is either equal to 100 or 120 and where the department ID is equal to 50. If we execute this SQL statement, in our query result now, we only return 13 rows. So the manager ID matches 100 or 120, and we'd show all employees for these two manager IDs that are in Department 50. By including the parentheses around the expression, we have overridden the default order of precedence, ensuring the correct expression is calculated first. In this video, we've covered the rules of precedence used to determine the order in which expressions are evaluated in the where clause in a SQL statement. In this video, we're going to learn how to retrieve rows in a specific order when executing a SQL statement. The order of rows that are returned in a query result is undefined, and we can use the order by clause to sort the rows. You can specify an expression, an alias, or a column position as the sort condition. The Oracle database first sorts rows based on their values for the first expression. Rows with the same value for the first expression are then sorted based on their values for the second expression, and so on. The order by clause is the last clause specified in a SQL statement and specifies the order in which the retrieved rows are displayed. These rows can be sorted in ascending or descending order. If the order by clause is not used, the Oracle server may not fetch rows in the same order for the same query twice. Use the order by clause to display the rows in a specific order. The default sort order is ascending. Numeric values are displayed with the lowest value first. Date values displayed with the earliest value first. Character values are displayed in alphabetical order from A to Z. Null values are displayed last for ascending sequences and first for descending sequences. You can, in addition, sort a column that is not in the select list. In the first example in the slide, we sort the result by the department ID descending. To reverse the order in which rows are displayed, specify the descending keyword after the column name in the order by clause. The second example in the slide makes use of the column alias specified for the salary column in the order by clause. Note, use the keywords null first or nulls last to specify whether returned rows containing null values should appear first or last in the ordering sequence. In the first example, we sort the query results by specifying the numeric position of the column in the select clause. The example sorts the result by department ID, as this is the column at the third position in the select clause. The second example sorts query results by more than one column. The columns listed in the order by clause are delimited by commas. The results are ordered by the first column, then the second, and so on, for as many columns as the order by clause includes. If you want to use any results sorted in descending order, your order by clause must use the descending keyword directly after the name or number of the relevant column. We are logged into our HR connection in Sql Developer. In our first example, we will create a SQL statement and we will display the salary for each employee sorted from lowest to highest. Our SQL statement is select first name, last name, and salary from employees, order by salary. As ascending is the default, we do not need to specify the keyword. We run our SQL statement. In the query result window, we can see that the rows are sorted by salary in ascending order. In the next example, we will select the annual salary for all employees in two departments, We will specify a column alias for the annual salary, and we will then sort the rows returned by department and their annual salary descending. Our SQL statement will look as follows. We select last name, department ID, salary, times 12 to calculate our annual salary as we give it a column alias. We select from the employees table and we order by department ID. We don't specify the keyword, so therefore by default it's ascending, and we specify the alias for our annual salary descending. We execute our SQL statement. In the query result window, we can see that our rows are sorted by department ID in ascending order, and for each department, the annual salary is ordered in descending order. You have now learned how to use the order by clause in a SQL statement to sort the order in which the rows are returned in the query result set. In Oracle Database 12c, the SQL select syntax has been enhanced to allow a row limiting clause, which limits the number of rows that are returned in the result set. The row limiting clause can be valuable for reporting, analysis, data browsing, and other tasks. Limiting row output is widely used and often referred to as top-n queries. Top-n queries sort their result set and then return only the first n number of rows. You can specify the number of rows or percentage of rows to return with the fetch first keywords. You can use the offset keyword to specify that the returned rows begin with a row after the first row of the full result set. The with ties keyword includes additional rows with the same ordering keys as the last row of the row limited results set. You must specify the order by in the query. The limitations when using the SQL row limiting clause: you cannot use it with the for update clause. You cannot use it in a subquery of a delete or update statement, and the select list cannot contain the sequence pseudo columns current val or next val. Specify the row limiting clause in the SQL select statement by placing it after the order by clause. An order by clause is required if you want to sort the rows for consistency. Some of the row limiting clause keywords: offset. Use this clause to specify the number of rows to skip before row limiting begins. If you specify null or a number greater than or equal to the number of rows that are returned by the query, 0 rows are returned. Fetch. Use this clause to specify the number of rows or percentage of rows to return. Row count, %. Use row count to specify the number of rows to return, and use % to specify the percentage of the total number of selected rows to return. Specify only to return exactly the specified number of rows or percentage of rows. Specify with ties to return additional rows with the same sort key as the last row fetched. If you specify with ties, then you must specify the order by clause. In this slide, the first code example returns the 5 employees with the lowest employee ID. The second example returns the 5 employees with the next set of lowest employee IDs. Note, if employee ID is assigned sequentially by the date when the employee joined the organization, these examples give us the top 5 employees and then employees 6 to 10, all in terms of seniority. We will now demonstrate the use of the row limiting clause in a SQL statement. We select first name, last name, and hire date. From employees, we will order by hire date, and we will fetch the first 10 rows only. We execute our SQL statement. In the query result window, only the first 10 rows are returned. As we sorted by hire date, these will be the first 10 employees that were employed. Next, we will select the top 10% of employees with the highest salaries. Our SQL statement will look as follows. We will select last name, department ID, and salary. From the employees table, we will order by salary descending, and we will fetch the first 10% of rows only. We execute our SQL statement. In the query result window below, we have retrieved the top 10% of rows. These are the top 10% employees with the highest salaries. In this video, we've covered the new Oracle Database 12c row limiting clause used in a SQL statement to limit the result set returned. In this video, we're going to look at how to pass values to a SQL statement in the form of substitution variables. So far, all SQL statements were executed with predetermined columns, conditions, and their values. Suppose that you want a query that lists the employees with various jobs, and not just those whose job ID is SA Rep. You could edit the where clause in the SQL statement to provide different values each time you run the command. But there is an easier way. By using a substitution variable in place of the exact values in the where clause, you can run the same query for different values. You can create reports that prompt users to supply their own values to restrict the range of data returned by using substitution variables. You can embed substitution variables in a command file or in a single SQL statement. A variable can be thought of as a container in which values are temporarily stored. When the statement is run, the stored value is substituted. The single ampersand and double ampersand substitution variables are used to temporarily store values. You can also predefine variables using the define command. Define creates and assigns a value to a variable. Substitution variables can be used to supplement the where clause, the order by clauses, column expressions, table names, and entire select statements. Some examples of restricted ranges of data are reporting figures only for the current quarter or a specified date range. Another example, reporting on data relevant only to the user requesting the report. And lastly, an example of displaying personnel with only a given department. The interactive effects are not restricted to direct user interaction with the where clause. The same principles can be used to achieve other goals, such as you can obtain input values from a file rather than from a person, and you can pass values from one SQL statement to another. Both Sql Developer and Sqlplus support substitution variables and the define and undefined commands. When running a report, users often want to restrict the data that is returned dynamically. Sqlplus or Sql Developer provide this flexibility with user variables. Use an ampersand to identify each variable in your SQL statement. However, you do not need to define the value of each variable. The example in the slide creates a Sql Developer substitution variable for an employee number. When the statement is executed, Sql Developer prompts the user for an employee number and then displays the employee number, last name, salary, and department number for that employee. With the single ampersand, the user is prompted each time the command is executed if the variable does not exist. When Sql Developer detects that a Sql statement contains an ampersand, you are prompted to enter a value for the substitution variable that is named in the Sql statement. After you enter the value, click on the OK button and the results are displayed. We are now in our Sql Developer session and connected to our HR connection. We will demonstrate the use of the single ampersand substitution variable in a Sql statement. We will select all employees in a specific department and we will be prompted to enter the department ID. Our Sql statement looks as follows. Select first name, last name, and department ID from employees where department ID is equal to, and we specify our ampersand, department ID. We execute our Sql statement. We are prompted for a department ID. We will enter department ID 10. We click on the OK button, and all employees in department 10 are displayed in the query result window. You have now learnt about substitution variables and how to use the single ampersand substitution variable to temporarily store values to be passed to a Sql statement and thereby allowing you to dynamically restrict the data returned. In a Sql statement, substitution variables are used to substitute column names, expressions, and text. In a where clause, the date and character values must be enclosed within single quotation marks. The same rule applies to the substitution variables. Enclose the variable with single quotation marks within the Sql statement itself. The slide shows a query to retrieve the employee names, department numbers, and annual salaries of all employees based on the job title value of the Sql Developer substitution variable. Substitution variables are used not only in the where clause of a Sql statement, but also as substitution for column names, expressions, or text. The example in the slide displays the employee number, last name, job title, and any other column that is specified by the user at runtime from the employees table. For each substitution variable in the select statement, you are prompted to enter a value, then click OK to proceed. If you do not enter a value for the substitution variable, you get an error when you execute the preceding statement. Note, a substitution variable can be used anywhere in the select statement except as the first word entered at the command prompt. In our first Sql statement, we will demonstrate how to use character values when working with substitution variables. We will define the character value for the job ID. Our Sql statement looks as follows. We will select last name, department ID, salary times 12 for the annual salary from the employees table where job ID is equal to, and in single quotes we enter our substitution variable. We will call it job title, close our single quotes, and we execute our Sql statement. For our substitution variable, we will enter IT_prog. To list all IT programmers within the employees table, we click on OK. In the query result window, all employees with a job title of IT_prog have been returned. In our next Sql statement, we will demonstrate how to use substitution variables to specify column names, expressions, and text in a Sql statement. We're going to add a substitution variable for a column name in the select list and a substitution variable in the where clause. Our Sql statement will look as follows. We will select last name, manager ID, and we will enter the substitution variable column name. So we will enter a column name at the execution of this SQL statement. We're selecting from the employees table where manager ID is equal to and the substitution variable manager ID. We execute our SQL statement. For the column name, we're going to view the salary column for the employees that are returned. We click on OK, and we're going to request all records where the manager ID is 103. In the query result window, we can see the substitution variable column name has returned the salary column in our query result, and all records are filtered by manager ID 103 as per the manager ID substitution variable. In this video, we've covered how to work with substitution variables when using character and date values, and how to use substitution variables to specify column names, expressions, and text in a SQL statement. In this video, we're going to learn how to reuse a substitution variable in a SQL statement and how to use a substitution variable in a Sqlplus session. You can use the $& substitution variable if you want to reuse the variable name without prompting the user each time. The user will see the prompt for the value only once. In the example in the slide, the user is asked to give the value for the variable column name only once. The value that is supplied by the user, department ID, is used to display the column data and in the ordering of the data. If you want to run the query again, you will not be prompted for the value of the variable. Sql Developer stores the value that is supplied by using the define command. It uses it again whenever you reference the variable name. After a user variable is in place, you need to use the undefined command to delete it. This slide demonstrates how to use the & substitution variable in Sqlplus. You will be prompted to enter a value. The old and new values will be displayed and the data returned. We are connected to our HR connection in Sql Developer, and we will write a SQL statement demonstrating the use of the $& substitution variable. In our SQL statement, we specify the variable column name in two places in the SQL statement, in the select list, and we use the same variable column name in the order by clause. Our SQL statement looks as follows. We will select the employee ID, the last name, job ID, and we will specify our $& variable, column name. We're selecting from the employees table, and we will order by the substitution variable, column name. We execute our SQL statement. As we had previously defined the variable column name, we were not prompted to enter the column name. First, we will undefine the variable. And we will then re-execute our SQL statement. We are prompted to enter a column name. We will enter department ID. Click on OK. We only had to enter department ID once. The output in the query result window, the data for our department ID column is returned in our SQL statement. We can see that our data is ordered by department ID. To demonstrate this SQL statement in a Sqlplus session, we've pasted our SQL statement into our Sqlplus session. We enter to execute it. We are prompted to enter the value for the column name variable, and the data is returned. The department ID column is included in the output of our SQL statement, and our query is ordered by department ID. You have now learned how to use the $& substitution variable in a SQL statement. In this video, we're going to learn how to use the define and verify commands to create, assign, and verify a substitution variable when using SQL Developer. The define command is used to create and assign a value to a variable. The undefined command is used to remove a variable. The example in the slide creates a substitution variable for an employee number by using the define command. At runtime, this displays the employee number, name, salary, and department number for that employee. Because the variable is created using the SQL Developer define command, the user is not prompted to enter a value for the employee number. Instead, the defined variable value is automatically substituted in the select statement. The employee_num substitution variable is present in the session until the user undefines it or exits the SQL Developer session. The verify command is used to toggle the display of the substitution variable, showing both SQL statements before and after SQL Developer replaces substitution variables with values. To confirm the changes in the SQL statement, use the verify command. Setting Set Verify On forces SQL Developer to display the text of a command after it replaces substitution variables with values. To see the verify output, you should use the Run Script icon in the SQL worksheet. SQL Developer displays the text of a command after it replaces substitution variables with values, in the Script Output tab as shown in the slide. The example in the slide displays the new value of the employee ID column in the SQL statement followed by the output. Sqlplus uses various system variables that control the working environment. One of the variables is verify. To obtain a complete list of all system variables, you can issue the Show All command on the Sqlplus command prompt. To demonstrate using the define command, we are logged into our HR connection in SQL Developer. In the Sql Worksheet window, we start by entering the define command and the variable that we're going to define. We're going to set department ID equals to 100. We then enter our SQL statement. We select employee ID, last name, salary, and department ID from the employees table, where department ID is equal to a substitution variable, department ID. We then execute our script. We did not need to enter a value for the substitution variable in our SQL statement, as we had used the define command to set a value for the variable. To unset a variable, we use the undefined command. We undefine department ID. We execute this command. If we then rerun our SQL statement, we are prompted to enter a value for the department ID. To demonstrate the use of the verify command, we add in set verify on, and we then run our script. In the script output window, we can see the old SQL statement and the new SQL statement after the substitution variable has been replaced with a value. You are now ready to use the define and verify commands to create, assign, and verify a substitution variable when using SQL Developer. Now that you've learned how to restrict and sort data using the where clause, the order by clause, and substitution variables, it is now time to put that knowledge to work. In this exercise, you will display the last names of all employees who have both an A and an E in their last name. Next, you will create a query to run reports based on a manager. The query must prompt the user for the manager ID and generate the employee ID, last name, salary, and department for the manager's employees. Lastly, you will update the SQL statement to ensure that the report can be sorted on a selected column. Test the data with the following values: Manager ID 103 and order by the last name. Then test with Manager 201, sorting the data by salary. And lastly, Manager 124, sorting by employee ID. When you are ready, pause this video, perform the exercise. When you are done, come back to the video and I will work through the exercise with you. To demonstrate the exercise, we are logged into Sql Developer and connected to the HR sample schema. In our first SQL statement, we're going to display the last name of all employees who have both an A and an E in their last name. The SQL statement will look as follows. Select last name from the employees table where last name like A and last name like E. We execute this SQL statement. In the query result window, all employees who have a last name which contain the letters A and E are returned. Next, we're going to create a SQL statement that will return the columns employee ID, last name, salary, and department, and we will prompt for a manager ID at the time that the SQL statement executes. The query will look as follows. Select employee ID, last name, salary, department ID from employees where manager ID is equal to, and we'll pass a substitution variable for manager ID. We execute this SQL statement. We are prompted for our manager ID. We will enter 100. In the query result, all employees who belong to manager 100 are returned. Next, when we execute the SQL statement, in addition to prompting for the manager ID, we would like to decide at this point which column the data should be sorted on. To do this, we're going to extend our SQL statement to order by, and we'll pass a substitution variable for column name. We execute our SQL statement. Based on the values specified in the slide, for the first example, we enter manager 103, and we're going to sort it by the last name. In the query result, all employees who have a manager 103 are returned, and the data is sorted by the last name. We'll run the next example. We'll enter manager 201, and we'll order by the salary column. All employees for manager ID 201 are now returned, and the data is sorted by the salary column. Lastly, we will run the example for manager 124, and we will sort the data by the employee ID. In the query result, all employees who have a manager ID of 124 are returned, and the data is sorted by the employee ID. In this video, we will introduce SQL functions, identify the types of SQL functions available in a SQL statement, and describe single row functions. Functions are a very powerful feature of SQL, and they can be used to perform calculations on data, modify individual data items, manipulate output for groups of rows, format dates and numbers for display, and convert column data types. Input can be passed to a function in the form of an argument, and a function will always output a result value. Do not confuse SQL functions with user-defined functions written in Pl SQL. There are two types of functions, single-row functions and multi-row functions. Single-row functions operate on single rows only and return one result per row. There are different types of single-row functions, and in future videos, we will cover the character, number, and date single-row functions. Multiple-row functions can manipulate groups of rows to give one result per group of rows. And we will learn about these functions in a future lesson titled Reporting Aggregated Data Using Group Functions. For a complete list of available functions and their syntax, see the Functions sections of the Oracle Database SQL Language Reference for Database 12c. Single-row functions are used to manipulate data items. A single-row function accepts one or more arguments and returns one value for each row that is returned by the query. An argument can be one of the following: a user-supplied constant, a variable value, a column name, or an expression. The feature of single-row functions include acting on each row that is returned in the query, returning one result per row, possibly returning a data value of a different type than the one that is referenced, possibly expecting one or more arguments, and single-row functions can be used in the select, where, and order by clauses, and can be nested. The syntax for a single-row function is the function name, and then an argument is passed that is to be used by the function. This can be represented by either a column name or expression. The single-row functions that we will work with is the character function. This accepts character input and can return both character and number values. The number function accepts numeric input and returns numeric values. Date functions operate on values of the date data type. The following single-row functions are discussed in the lesson titled Conversion Functions and Conditional Expressions. The conversion function converts a value from one data type to another. And general functions. These functions take any data type and can also handle nulls. In this video, we've covered SQL functions. You have learnt about the types of SQL functions, and you are now ready to start working with single-row functions. Using character functions in a SQL statement. Single-row character functions accept character data as input and can return both character and numeric values. Character functions can be divided into case conversion functions and character manipulation functions. The functions that we will discuss in this learning path are only some of the available functions. Looking now in more detail at the character functions, the first three, lower, upper, and init cap, are known as case conversion functions. The remaining functions, concat and substring, are known as character manipulation functions. The lower function converts alpha character values to lowercase. The upper function converts alpha character values to uppercase. The init cap function converts the first alpha character value to uppercase for the first letter of each word. All other letters are in lowercase. The concat function concatenates the first character value to the second character value, and it is equivalent to the concatenation operator. The sub-str function returns the specified characters from a character value starting at character position m for n characters long. If m is negative, the count starts from the end of the character value. If n is omitted, all characters to the end of the string are returned. Continuing with the character manipulation functions, Next is the length function. This function returns the number of characters in the expression. The instr function returns the numeric position of a named string. The lpad function returns an expression left padded to the length of n characters with a character expression. The rpad function returns an expression right padded to the length of n characters with a character expression. The trim function enables you to trim leading or trailing characters or both from a character string. And the replace function. The replace function searches a text expression for a character string and, if found, replaces it with a specified replacement string. You are now ready to extend your SQL statements by making use of character functions. In this video, we're going to learn how to use the case conversion functions in a SQL statement. Lower, upper, and init cap are the three case conversion functions used to convert the case for character string. Lower converts mixed case or uppercase character strings to lowercase. Upper converts mixed case or lowercase character strings to uppercase. Init cap converts the first letter of each word to uppercase and the remaining letters to lowercase. The example in the slide displays the employee number, name, and department number for employee Higgins. The where clause of the first SQL statement specifies the employee name as lowercase Higgins. Because all the data in the employees table is stored in a proper case, the name Higgins does not find a match in the table, and no rows are selected. The where clause of the second SQL statement specifies that the employee name in the employees table is compared to lowercase Higgins, converting the last name column to lowercase for comparison purposes. Because both names are now lowercase, a match is found and one row is selected. The name in the output appears as it was stored in the database. To demonstrate the use of the case conversion functions, in our first SQL statement, we will write a query that displays the last name with the first letter in uppercase and all other letters in lowercase. For all employees whose name starts with the letters J, A, or M, we will give each column an appropriate label and sort the results by the employee's last name. Our SQL statement will look as follows. We will select init cap, in brackets, last name. We will give it a column alias, name. We're selecting from the employees table, where last name, like, and we're looking for all employees that last name starts with a capital letter J, or where the last name is like capital letter M, or where last name is like the capital letter A. We order our SQL statement by the last name. We execute this SQL statement. In the query result window, all employees with the last name starting with capital letter J, M, and A are returned with the first letter in uppercase and the remaining letters in lowercase, and the last name is sorted in ascending order. Next, we will rewrite the query so that the user is prompted to enter the letter that the last name starts with. For example, if the user enters a capital H when prompted for a letter, the output should show all employees whose last name starts with the letter H. Our SQL statement will look as follows. We select init cap for last name. We give it an alias from the employees table, where last name, like, We will enter a substitution variable to prompt for the first letter of the last name. And we will order by last name. We execute this SQL statement. We are prompted for a letter. We will enter the letter capital H. We click on OK. And all employees with the last name starting with a capital H are returned. We will now modify the query such that the case of the letter that is entered does not affect the output. The entered letter must be capitalized before being processed by the select query. To do this, we enclose our substitution variable with the upper function. We execute our SQL statement. If we enter a lowercase h and we click on OK, all employees with a capital H are returned. We will rerun this example. We will enter a lowercase a, so we would like all employees with the last name starting with an A to be returned. We click on OK, and we can see in the query result, all employees starting with a capital letter A in their last name are returned. You are now ready to use character case conversion functions in your SQL statements. Learning how to use character manipulation functions in our SQL statements. These functions are used to manipulate character strings. The concat function joins two values together. The substring function extracts a string of determined length. The length function shows the length of a string as a numeric value. The instring function finds the numeric position of a named character. Lpad returns an expression left padded to the length of n characters with a character expression. Rpad returns an expression right padded to the length of n characters with a character expression. In the example in the slide, we display employee last names and job IDs joined together with a column alias and who have the string rep contained in the ID column starting at the 4th position. We made use of the concat function to join the last name and the job ID and the substring function to identify the word rep in the job ID column. In this example, we use the following character manipulation functions. The concat function to join the first name and the last name columns, the length function to show the length of the columns for the last name of each employee, the instring function to show the position of the letter A in the last name column, and in the where clause, we use the substring function to return only rows where the employee's last name ends in an N. We are logged into our HR connection in Sql Developer, and we will demonstrate how to use the Lpad and Rpad character manipulation functions in a SQL statement. We're going to create a query to display the last name and salary for all employees. The first salary column will be 15 characters long, left padded with the dollar symbol, and it will have a label salary. The next column will indicate the amount of the employee's salary with asterisks. Each asterisk signifies $1,000, and the data will be sorted in descending order of salary. This column will be labeled employees and their salaries. Our SQL statement will look as follows. We will select last name. For the Lpad function, we will use Lpad salary column for 15 characters long, and we will left pad it with the $sign. We will give this a column alias called salary. Our next column, we will right pad. Our salary column will be divided by 1,000. Each asterisk will indicate $1,000. And we will specify that we're using the asterisk. And our column alias will be employees and their salaries. We will select from the employees table, and we will order by salary descending. We execute our SQL statement. In our query result window, we display the last name. We display our salary column where we left padded 15 characters with the $sign and the salary value. And our next column is the employees and their salaries. These salaries are indicated by the asterisk, $1,000 per asterisk, and sorted in descending order. Now you know how to use the concat, substring, length, instring, lpad, and rpad character manipulation functions in your SQL statements. Nesting single-row functions in a SQL statement. Single-row functions are the character, number, date, conversion, and general functions used in a SQL statement to manipulate data items. Single-row functions can be nested to any depth and are evaluated from the innermost level to the outermost level. The example in the slide displays the last name of the employees in Department 60. The evaluation of the SQL statement involves 3 steps. The first, the inner function retrieves the first 8 characters of the last name. The result is substring last name from the first letter for 8 characters. The result of this function is concat result1 with the character string _US. Next, the outer function concatenates the result with _US. The result of this function is concat result1 with the character string _US. The outermost function converts the results to uppercase. As no column alias was given, the entire expression becomes the column heading. To demonstrate how to nest single-row functions in a SQL statement, we are logged into Sql Developer and connected to our HR connection. We will demonstrate building up our nested function until we have nested all the required functions, and we will demonstrate the output at each step. In our SQL statement, to demonstrate single-row nesting, we will include the upper, concat, and substring functions, and include a character string. The output of our query should be the sentence, employee last name has an initial of and the first letter of the employee's first name. We will select upper last name from the employees table where department ID is equal to the variable department ID. So we will pass the department ID number when we execute our SQL statement. We will order our query by the last name. We execute this first step. We enter department ID 60. In the output, we have all employees in department 60 with their last names in uppercase. Next, we will concatenate the last name with a character string. We add in the concat function. We then add in our character string. We execute our SQL statement. In the query result, we can now see we have the last name in uppercase, and it is concatenated with our character string, has an initial of. Next, we would like to add in the first letter of the employee's first name. We'll first create this as a separate function. We will add in substring, first name, starting at position 1 for 1 character. we execute the SQL statement to check the validity of the function at each step. If we build an entire function and we encounter an error, it is more difficult to troubleshoot. So by building it up in little blocks, we're able to ensure that our SQL statement works correctly at each step in our building block. In our query result, we can now see we have another column which contains the first letter of the employee's first name. We would now like to concatenate both columns into a single sentence. To do this, we will concat the first column with the last column. We will enclose it in brackets, and we will execute our SQL statement. We will see in the output that we don't have a space between the character string and the first letter. To correct that, I will add in a space in the character string. We'll execute the statement to double check that it is correct. And we can now see that we have our sentence. Austin has an initial of capital D. The last thing I'm going to do is give this column an alias. We'll add in employee information. So now when we execute our SQL statement, in the query result, our column now has the heading Employee Information. You have now learned how to nest single-row functions in a SQL statement. Numeric functions accept numeric input and return numeric values. Some of these functions are the round function. The round function rounds the value to a specified decimal. The trunc function truncates a value to a specified decimal. The ceil function returns the smallest whole number greater than or equal to the specified number. The floor function returns the largest whole number equal to or less than a specified number. And the mod function. The mod function returns the remainder of m divided by n. The number functions listed in the slide are only some of the available numeric functions. For a full list of the numeric functions, see the Oracle Database SQL Language Reference Document for 12C. The example in the slide shows the result of the value returned for each of these functions. The round function rounds the column, expression, or value to n decimal places. If the second argument is 0 or is missing, the value is rounded to 0 decimal places. If the argument is 2, the value is rounded to 2 decimal places. Conversely, if the second argument is -2, the value is rounded to 2 decimal places to the left, rounded to the nearest unit of 100. Introducing the dual table. This table is owned by the user sys and can be accessed by all users. It contains one column called dummy and one row with the value x. The dual table is useful when you want to return a value only once. For example, the value of a constant, pseudocolumn, or expression that is not derived from a table with user data. The dual table is generally used for completeness of the select clause syntax. Because both select and from clauses are mandatory and several calculations do not need to select from the actual tables. The trunc function truncates the column, expression, or value to n decimal places. The trunc function works with arguments similar to those of the round function. If the second argument is 0 or is missing, the value is truncated to 0 decimal places. If the second argument is 2, the value is truncated to 2 decimal places. Conversely, if the second argument is -2, the value is truncated to 2 decimal places to the left. To demonstrate the round function, we are going to select from the dual table and will demonstrate the effect on the output dependent on the argument passed in the round function. Our select statement looks as follows. We're selecting from the dual table, and we're going to select 4 round functions. In the first round function, we pass the argument of 2. In our second round function, we pass the argument of 0. In our third round function, we do not pass an argument. And in our fourth round function, we pass the argument of -2. We execute this SQL statement. In the query result, the first function where the second argument is equal to 2, the output value is rounded to 2 decimal places. In the next 2 functions, we include a 0 and we leave out the second argument. In these cases, the value was rounded to 0 decimal places. The last function, where we included an argument of -2, the value is rounded to 2 decimal places to the left and rounded to the nearest unit of 100. In our next SQL statement, we use the same values to demonstrate the impact of the trunc function. Our SQL statement looks as follows. In our first trunc, we pass the argument of 2. In our second trunc, we pass the argument of 0. In our third trunc function, we do not pass an argument, and in our fourth trunc function, we pass a -2. When we execute this SQL statement, we can see in the query result window, the first trunc function where we passed an argument of 2, the value is truncated to 2 decimal places. In the next 2 functions where the argument is 0 or missing, the value is truncated to 0 decimal places. And in the last function, where we specified a -2, here the value is truncated 2 decimal places to the left. If we execute both SQL statements now, comparing the round and the trunc functions, we can see in our query result window the impact that the round function and the trunc function have on the output of the value. In this video, we introduced the numeric functions and demonstrated how to use the round and trunc functions in your SQL statement. In this video, we're going to describe the mod number function and demonstrate how to use the mod function in a SQL statement. The mod function finds the remainder of the first argument divided by the second argument. The example in the slide displays the employee records where the employee ID is equal to an even number. The mod function is often used to determine whether a value is odd or even. To demonstrate how to use the mod function, in our first SQL statement we will select from the dual table, and our mod function will return the remainder of 11 divided by 4. Our SQL statement is select mod, and in brackets 11 divided by 4 from dual. We execute our SQL statement, and in the query result window below, we have the result of 11 divided by 4. In our next SQL statement, we're going to list all employees whose employee ID value is an odd number. Our SQL statement will look as follows. We will select employee ID, last name, and department ID from the employees table where mod, we specify the employee ID column and we pass 2 as the second argument, and where that is not equal to 0. We execute our SQL statement. In the query result window, a list of employees is displayed where their employee ID is equal to an odd number. We have described the mod function and demonstrated how to use the mod function in a SQL statement. In today's lesson, we will learn how to work with dates in a SQL statement and describe the RR-date format. The Oracle database stores dates in an internal numeric format, representing the century, year, month, day, hours, minutes, and seconds. The default display and input format for any date is dd-mon-rr. This enables you to store 21st century dates in the 20th century by only specifying the last 2 digits of the year, and to store the 20th century dates in the 21st century in the same way. Valid Oracle dates are between January 1, 4712 BC and December 31, 9999 AD. In the example in the slide, the higher date column output is displayed in the default format dd-mon-rr. Dates are, however, not stored in the database in this format. All the components of the date and time are stored. So, although a higher date, such as 17 June 03, is displayed as day, month, year, there is also time and century information associated with the date. The RR date format is similar to the YY element, but it can be used to specify different centuries. Use the RR date format element instead of YY so that the century of the return value varies according to the specified 2-digit year and the last 2 digits of the current year. The table in the slide summarizes the behavior of the RR element. If the 2-digit year specified and the 2 digits of the current year are 0 to 49, then the current date is in the current century. However, if the 2-digit year specified is 0 to 49 and the current year is between 50 and 99, then the return date is in the century after the current one. If the 2-digit year specified and the 2 digits of the current year are 50 to 99, then the current date is in the current century. If the 2-digit year specified is 50 to 99 and the current year is between 0 and 49, then the return date is in the century before the current one. In the example in the slide, in the first line the current year is 94 and the given date is between 50 and 99. Therefore, the date returned is in the current century. In the second line, however, the current year is 94 and the given date is 2017. Therefore, the interpreted date is the century after the current one. As a reminder, the data is stored internally in century, year, month, day, hour, minute, and seconds. You now know how the date format is stored in the Oracle database and how the date is interpreted when using the RR and YY date formats. In this video, we will introduce and demonstrate the use of the sysdate function, the current date function, and the current timestamp function. Sysdate is a date function that returns the system date. You can use sysdate just as you would use any other column name. For example, you can display the system date by selecting sysdate from a table. It is customary to select sysdate from the public table called dual. Note, sysdate returns the current date and time set for the operating system on which the database resides. Therefore, if you are in a place in Australia and connected to a remote database in a location in the United States, the sysdate function will return the United States date and time. In that case, you can use the current date function that returns the current date in the session's time zone. The current date and current timestamp functions return the current date and current timestamp respectively. The session time zone function returns the value of the current session's time zone. The return type is a time zone offset or a time zone region name, depending on how the user specified the session time zone value in the most recent alter session statement. The example in the slide shows that the session time zone is offset to UTC by -5 hours. Observe that the database time zone is different from the current session's time zone. In our first SQL statement, we will demonstrate selecting the sysdate from the dual table. We select sysdate from dual. The result window displays the current date on the database server. By default, we display the date only. We would need to alter our session to display the current time as well. We will need to run the alter session statement to include the time in the output. We can select sysdate from a valid table. We select sysdate, employee ID, last name from the employees table. We execute this SQL statement. In the query result window, the sysdate is returned for each row returned from the employees table. To view the full date and time, we can alter our session. We use alter session, set, NLS date, format, equal to, and the date format that you wish to see. We will enter month, DD, YY, so we will see month, day, year. We will include our date format. We execute our alter session statement. If we then rerun our SQL statement, we can now see that our sysdate is returned in the format that we set by the NLS date format parameter. We can see the date and the time. To display the current date and current timestamp in the session's time zone, we select current date and current timestamp from dual. We have covered the sysdate, current date, and current timestamp functions available, and how to select the current date and time using these functions. How to use arithmetic expressions with dates in a SQL statement. The database stores dates as numbers, and you can therefore perform calculations using arithmetic operators such as addition and subtraction. You can add and subtract number constants as well as dates. You can add to or subtract a number from a date for a resultant date value. You can subtract two dates to find the number of days between those dates. And you can add hours to a date by dividing the number of hours by 24. The example in the slide displays the last name and the number of weeks for which each employee in Department 90 has been employed. It subtracts the date on which the employee was hired from the current date, the sysdate, and then divides the result by 7 to calculate the number of weeks that a worker has been employed. To demonstrate how to use arithmetic expressions with dates, we would like to see how many days each employee has been employed by the company. Our SQL statement will include a character expression, the concatenation operator, a column alias, and the use of an arithmetic expression with dates. Our SQL statement will look as follows. We will select first name. We will concatenate the first name and the last name with a space. We will then include a character string, has been employed for. We will close our character string and we will concatenate the character string with the date calculation. We will take the sysdate minus the hire date. We will then add one last character string, days. We will close our character string and we will give our column an alias, days employed. We will select from the employees table where department ID is equal to the substitution variable department ID. So we will prompt for a department ID when we execute this SQL statement, and we will order our data by last name. We execute the SQL statement. We will enter department ID number 90. In our query result, we have a sentence displaying the number of days that each employee has been employed in department 90, and we sorted the results by the employee's last name. You are now ready to use arithmetic expressions with dates in your SQL statements. In this video, we will cover the use of the date functions, months between, add months, next day, and last day in a SQL statement. Date functions operate on Oracle dates. All date functions return a value of the date data type, except months between, which returns a numeric value. Months between finds the number of months between date 1 and date 2. The result can be positive or negative. If date 1 is later than date 2, the result is positive. If date 1 is earlier than date 2, the result is negative. The non-integer part of the result represents a portion of the month. The add months function adds n number of calendar months to the date. The value of n must be an integer and it can be negative. The next day function finds the date of the next specified day of the week following the date. The value of char may be a number representing a day or a character string. Last day finds the date of the last day of the month that contains the date. This list is a subset of the available date functions. The round and trunc number functions can also be used to manipulate date values. The round function returns date rounded to the unit that is specified by the format model. If the format model is omitted, date is rounded to the nearest day. The trunc function returns date with the time portion of the day truncated to the unit that is specified by the format model. If the format model is omitted, date is truncated to the nearest day. The format models are covered in detail in the lesson titled Conversion Functions and Conditional Expressions. The months between function in the example shows the number of months between the 11th of January 2004 and the 1st of September 2005. In the second example, the add months function adds 1 month to the supplied date value of 31st January 2004 and returns 29 February 2004. The function recognizes the year 2004 as the leap year and therefore returns the last day of the February month. If you change the input date value to the 31st of January 2005, the function will return 28 February 2005. The next day example displays the date of the Friday after the 1st of September 2005. And the last day function displays the last date of the month that contains the date. To demonstrate the use of the date functions, we will write a SQL statement to display the employee number, the hire date, the number of months employed, a 6-month review date, the first Friday after the hire date, and the last date of the hire month for all employees who have been employed for fewer than 150 months. Our SQL statement will look as follows. We will select Employee ID. We will select the hire date. To select the number of months employed, we will use the months between function, and we specify our dates between the sys date and the hire date. We will give this column an alias called tenure. Next, we will calculate the 6th-month review date. For this, we will use the add months function. We will specify the hire date column and the variable 6. The alias for this column will be called review. Next, we will calculate the date of the Friday after the hire date. For this, we will use the next day function. We specify the hire date and Friday. Lastly, we will calculate the last day of the month of the hire date. For this, we will use the last day function and we will specify the hire date. So the last day will be calculated based on the hire date. We're selecting from the employees table. In our where clause, we would like to see only employees who have been employed less than 150 months. For this, we will use the months between function and we specify sysdate and hire date where it is less than 150. We execute our SQL statement. In the query result, we display the employee number, their hire date, the number of months they've been employed, the 6-month review date, the date of the first Friday after the hire date, and the last day of the hire month for all employees. You are now ready to start using the date functions, months between, add months, next day, and last day in your SQL statements. Using the numeric round and trunc functions with dates. The round and trunc functions can be used for number and date values. When used with dates, these functions round or truncate to the specified format model. You can therefore round dates to the nearest year or month. When rounding, if the format model is month, dates 1 to 15 result in the first day of the current month. Dates 16 to 31 result in the first day of the next month. If the format model is year, months 1 to 6 result in January 1 of the current year. Months 7 to 12 result in January 1 of the next year. The example in the slide demonstrates the round and trunc functions using the month and year format models. To demonstrate how to use the round and trunc functions with a date, we are logged into Sql Developer and connected to our HR connection. We will compare the hire dates for all employees who started in 2004. We will display the employee number, the hire date, and starting month using the round and trunc functions. Our SQL statement will look as follows. Select employee ID, hire date. We will then round the hire date and pass it a format model of month. We will in addition use the trunc function, pass it the hire date and the format model month. We select from the employees table where the hire date is like 2004. We would like to see all employees with a hire date of 2004. We execute our SQL statement. In the query result window, for employee ID 120, the hire date is 18 July 2004. As the date is the 18th, the round function rounds the date to the first day of the following month. The trunc function returns the first day of the month in the hire date month. In this video, we have covered the use of the round and trunc functions with dates. Now that you've learned how to use the character and date single row functions to customize SQL statement output, it is now time to put that knowledge to work. In this exercise, you will write a query to display the system date. Label the column Date. Note if your database is remotely located in a different time zone, the output will be the date for the operating system on which the database resides. You will then create a report to display the employee number, last name, salary, and salary increase by 15.5% to be expressed as a whole number for each employee. Label the column New Salary. In the following task, Write a query to display the last name in sentence case and the length of the last name for all employees whose name starts with a capital J, A, or M. Label each column. Sort the results by the employees' last names. Lastly, rewrite the query so that the user is prompted to enter the letter that the last name starts with. For example, if the user enters an uppercase H when prompted, the output should show all employees whose last name starts with the letter H. When you are ready, pause this video, perform the exercise. When you are done, come back to the video and I will work through the exercise with you. To perform the tasks in the exercise, we are logged into Sql Developer and connected to the HR sample schema. The query to display the system date is select sysdate. We'll give it a column alias, date, from dual. We execute this SQL statement. In the query result window, the system date is displayed with our column heading date. Next, we will write a query to display the employee number, last name, salary, and salary increase by 15.5% expressed as a whole number for each employee. We will label the column New Salary. Our SQL statement will look as follows. Select Employee ID, last name, salary. This is the current salary for the employee. We will then round salary times 1.155 to a whole number, and we will give it a heading, New Salary. So in the round function, we've taken the salary, we've added on 15%, and we've rounded it to a whole number. We select from the employees table. We execute our SQL statement. In the query result window, we list all employees with their employee ID, last name, their current salary, and their new salary should they receive a 15% increase and expressed as a whole number. We will now write a query that displays the last name with the first letter in uppercase and all other letters in lowercase, and the length of the last name for all employees whose names start with the letter J, A, or M. We will give each column an appropriate label, and we will sort by the last name. Our SQL statement looks as follows. Select. We will use the init cap function. Last name. The column heading will be name. We will select the length of the last name column. We will give this column a heading, length. We're selecting from the employees table, where last name, like, a capital J, or last name, like, a capital M, or last name, like, a capital A. And we will order by last name column. We execute the SQL statement. In the query result window, all employees are returned whose last names start with a capital letter A, J, or M. We've included the length of the last name, and we've sorted by the last name. We are now going to rewrite the query so that the user is prompted to enter the letter that starts the last name. For example, if the user enters a capital H when prompted, the output should return all employees whose name starts with a capital letter H. To do this, we will replace the where clause in our SQL statement. We will say where last name, like. We'll enter a substitution variable for start letter. We execute this SQL statement. When we are prompted, we enter the first letter of the last name. We click on OK. And all employees whose last names start with a capital letter H are returned. In this video, we're going to look at the use of implicit and explicit data conversion within SQL statements. In addition to Oracle data types, columns of tables in an Oracle database can be defined by using the ANSI, DB2, and Sql DS data types. However, the Oracle server will internally convert such data types to Oracle data types. In some cases, the Oracle server receives data of one data type where it expects data of a different data type. When this happens, the Oracle server can automatically convert the data to the expected data type. This data type conversion can be done implicitly by the Oracle server or explicitly by the user. Explicit data type conversions are performed by using the conversion functions. Conversion functions convert a value from one data type to another. Generally, the form of the function names follows the convention data type to data type. The first data type is the input data type, and the second data type is the output. Note, although implicit data type conversion is available, it is recommended that you do the explicit data type conversion to ensure the reliability of your SQL statements. Looking now at implicit data type conversion. The Oracle server can automatically perform data type conversion in an expression. For example, the expression higher date greater than 01 Jan-90 results in the implicit conversion from the string 01 Jan-90 to a date. Therefore, a varchar2 or char value can be implicitly converted to a number or date data type in an expression. Note, char to number conversions succeed only if the character string represents a valid number. In general, the Oracle server uses the rule for expressions when a data type conversion is needed. For example, the expression job ID equals 2 results in the implicit conversion of the number 2 to the string 2 because job ID is a varchar2 column. In explicit data conversion, SQL provides three functions to convert a value from one data type to another. The toChar function converts a number or date value to a varchar2 character string with the format model. For number conversion, the NLS params parameter specifies the following characters which are returned by number format elements: a decimal character, a group separator, local currency symbol, and international currency symbol. If NLS params or any other parameter is omitted, this function uses the default parameter values for the session. The toNumber function converts a character string containing digits to a number in the format specified by the optional format model. The NLS params parameter has the same purpose in this function as in the toChar function for number conversion. The toDate function converts a character string representing a date to a date value according to format that is specified. If format is omitted, the format is dd-mon-yy. The NLS params parameter has the same purpose in this function as in the toChar function for date conversion. The list of functions mentioned in this lesson includes only some of the available conversion functions. For more information, see the Conversion Functions section in the Oracle Database SQL Language Reference for 12C. In this video, we introduced the use of implicit and explicit data conversion within SQL statements. Using the toChar function to convert a date to a character data type in a SQL statement. toChar converts a datetime data type to a value of varchar data type in the format specified by the format model. A format model is a character literal that describes the format of datetime stored in a character string. you can use the toChar function to convert a date from its default format to the one that you specify. Some guidelines when using the toChar function are: the format model must be enclosed within single quotation marks. It is case sensitive. The format model can include any valid date format element. To remove padded blanks or to suppress leading zeros, use the full mode FM element and separate the date value from the format model with a comma. The format of the toChar function is to_char and then in brackets the date or the column containing the date, comma, and in single quotes your format model and close brackets. In the example, the datetime format model for the string 11-NOV for November -2000, the format model would be DD-MON with a capital M -YYYY. The SQL statement in the slide displays the last name and hire dates for all employees. In the query result, the FM element is used to remove all padded blanks and suppress leading zeros. The month is expressed as a word, with the full year being displayed. To demonstrate the use of the toChar function to convert a date to a character data type in a SQL statement, in our SQL Developer session, we have the example as in the last slide. Select last name, and we did a toChar on the hire date with DD, month, and year. And you can see in the query result, we have the output. We are now going to modify this example to display the date in a format that appears as 17th of June 2003, 12 a.m. The query will look as follows. We select last name, toChar. We're selecting the hire date. And for our format element, to specify the day as a word, we'll use FM DDSPTH. We will in double quotes specify the of word. Month, to specify the month as a word. And we will then include our year and our time element. We close our single quotes and our bracket, and we select from the employees table. We execute this SQL statement. In the query result window, you can see in our output, we have the day in a word, the word of, the month written out as a word, our year, and 12 a.m. And that is how we use the toChar function to convert a date to a character data type in a SQL statement. In this video, we will describe the elements of the date format model in SQL. The main elements of the date format model are: for Ys returns a full year in numbers. The word year spells the year out in English. Returns a 2-digit value for the month. The word month returns the full name of the month. MON returns a 3-letter abbreviation of the month. DY returns a 3-letter abbreviation of the day of the week. The word day returns the full name of the day of the week. And DD returns the numeric day of the month. This slide displays a full list of the date elements that can be used in the date format model. The language in which these values are returned is specified by either explicitly setting the NLS_date_language initialization parameter or implicitly with the NLS_language parameter. The values returned by year and SYEAR format elements are always returned in English. Time elements format the time portion of the date. Character strings can be added by enclosing them within double quotation marks. and number suffixes spell out numbers. Looking now at the time element. We use the formats listed in the table to display time information and literals, and to change numerals to spelt numbers. AM or PM returns the meridian indicator. A.M returns the meridian indicator with periods. HH or H12 return the 12-hour format. HH24 returns a 24-hour format. MI returns minutes. SS returns seconds. And 5 S's return seconds past midnight. In our SQL Developer session, we have 3 SQL statements, each one demonstrating a different time or date element format. We are selecting the hire date of employee 207. I will execute the script. And in the script output, you can see the different date element formats returned by the SQL statements. In this video, we describe the elements of the date format model in SQL. In this video, we're going to learn how to use the toChar function when working with numbers. When working with number values, such as character strings, you should convert those numbers to the character data type using the toChar function, which then translates a value of a number data type to a varchar2 data type. This technique is especially useful when working with concatenation. In this slide, we display the most frequently used format elements used when converting a number to a character data type. The number 9 represents a numeric position. The number of 9s determines the display width of the column. The 0 displays leading zeros. A $sign places a floating $sign. A capital L uses the floating local currency symbol. A dot prints a decimal point, and the comma prints a comma as a thousands indicator. This slide provides a full list of the format elements that are available when converting a number to a character data type. In the example in the slide, the salary column is converted to a character data type with the number format returning the $sign. The number 9 determines the display width of the value returned. The comma represents the thousands separator, and the dot represents the decimal point. The output is displayed as $6,000 with the $sign, the comma, and the dot. The Oracle server displays a string of number signs, the hash sign, in place of a whole number where the digits exceed the number of digits provided in the format model. The Oracle server rounds the stored decimal value to the number of decimal places provided in the format model. We are logged into our HR connection in SQL Developer, and we're going to demonstrate 2 SQL statements using the toChar function when working with numbers. First, I'm going to do a describe on the employees table. The column that we're going to be working with is the salary column, and we can see it's a number data type. For our first SQL statement, we're going to select the salary column. We're going to use the toChar function. We'll specify the salary column, and then we'll specify our format element. We're selecting from the employees table, and we execute our SQL statement. In the query result, as we specified the S element, it shows whether we return a positive or a negative value. The 0 element returns leading zeros, and the number 9s determine the numeric position, therefore indicating the display width of the column. For our next example, we're going to output a sentence. We're going to select the employee ID, and for our sentence, I'm going to break it down into smaller portions. We'll execute the statement at each portion to ensure that it's working correctly. First, we're going to select the last name and we'll concatenate that with the sentence. We will use the concat function. We specify last name and our character string that we're going to return is earns a salary of. We close our string. We select from the employees table. We execute this statement to ensure that it's working correctly. Next, we're going to extend our SQL statement and we're going to concatenate that string with the salary. We will add the concat function. And at the end of the string, we will add on the salary column that we wish to concatenate with. We're going to use the tochar function. We specify our salary column. And then we specify our format element. We would like to return the $sign. We'll use the thousand separator. We'll return 2 decimal points. We close our bracket. We will give our column a heading. We execute our SQL statement. And in the query result, you can see that we have returned the employee last name, the character string earns a salary of, and our salary is returned in the format that we specified in our SQL statement. You are now ready to make use of the tochar function to display a number value as a character in your SQL statements. Using the toNumber and toDate function to convert a character data type to a number or date format in a SQL statement. You may want to convert a character string to either a number or a date. To accomplish this task, use the toNumber or toDate functions. The syntax for the toNumber function is to_number, the character string, and the format model. The number format model is based on the number elements previously demonstrated. To convert a date, the syntax is to_date. You pass the character string and specify the format model. The format model is based on the date format elements that were previously demonstrated. The fx modifier specifies the exact match for the character argument and the date format model of a toDate function. Punctuation and quoted text in the character argument must exactly match the corresponding parts of the format model except for case. The character argument cannot have extra blanks. Without fx, the Oracle server ignores extra blanks. Numeric data in the character argument must have the same number of digits as the corresponding element in the format model. Without fx, the numbers in the character argument can omit leading zeros. In the example in this slide, we display the name and hire date for all employees who started on May 24, 2007. As there are 2 spaces after the month May and before the number 24 in the example, and because the fx modifier is used, an exact match is required, and the spaces after the word May are not recognized. This will result in an error 01858. To resolve this, simply remove the space between May and 24, and the SQL statement will execute successfully. To demonstrate an example of a toNumber and a toDate function, we're going to write a SQL statement to select from the dual table. We will select toNumber. We pass our character string. We specify the format model. We're going to give our column an alias called number. Next, we will include the toDate function. We pass our character string. We pass the format model for the character string. We give this column a heading. And we select from dual. We execute the SQL statement. In the query result, in our number column, we return a number data type, and in the date column, we return a date data type. In this video, we've covered the use of the toNumber and toDate functions to convert a character data type to a number or date format in a SQL statement. In this video, we're going to look at how to use the toChar and toDate functions with the RRDate format to return data for a previous century in a SQL statement. In the example in the slide, to find employees who were hired before 1990, the RR format can be used. Because the current year is greater than 1999, the RR format interprets the year portion of the date from 1950 to 1999. Alternatively, the following command results in no rows being selected because the YY format interprets the year portion of the date in the current century, 2090. Looking now at an example of a SQL statement where we first pass the YY date format in the where clause of the statement, we will then update the SQL statement to use the RR format, and we will review the results that are returned. Our SQL statement will look as follows. Select last name. We will then return the date using the toChar function. We're going to return the hire date in the format dd-mon-YYYY. We close the format. We're selecting from the employees table where we then use the toDate function. We're going to compare the hire date with the date value. We specify the hire date column, and we then specify the format of that date, dd-mon-YY. We would like to see all employees with a hire date of less than 01 Jan 96. We execute this SQL statement. In the query result, we can see that no rows were returned. This is due to us using the YY date format in our where clause. The YY format interprets the year portion of the date in the current century. Next, we're going to update our SQL statement. We'll update our where clause to use the RR format. We will execute the same SQL statement. In the query result, we now have one row that is returned. Because the current year is greater than 1999, the RR format specified in our where clause interprets the year portion of the date from 1950 to 1999, and therefore we have one row returned by our SQL statement. In this video, we've covered how to use the toChar and the toDate functions with the RRDate format when returning data for a previous century in a SQL statement. In this video, we will describe the general functions used when working with data pertaining to null values. These functions work with any data type and pertain to the use of null values in the expression list. The NVL function converts a null value to an actual value. NVL lets you replace a null, which is returned as a blank, with a string in the results of a query. If expression 1 is null, then NVL returns expression 2. If expression 1 is not null, then NVL returns expression 1. The arguments can have any data type. If their data types are different, the Oracle database implicitly converts one to the other. If they cannot be converted, the database will return an error. The NVL2 function. NVL2 lets you determine the value returned by a query based on whether a specified expression is null or not null. If expression 1 is not null, then NVL2 returns expression 2. If expression 1 is null, then NVL2 returns expression 3. The argument expression 1 can have any data type. The arguments for expression 2 and expression 3 can have any data type except a long. The null if function compares two expressions and returns a null if they are equal. If they are not equal, then the function returns expression 1. If both arguments are numeric data types, then the Oracle database determines the argument with the higher numeric precedence, implicitly converts the other argument to that data type, and returns that data type. If the arguments are not numeric, they must be of the same data type, or the Oracle database will return an error. Looking now at the coalesce function, coalesce returns the first non-null expression in the expression list. You must specify at least two expressions. If all occurrence of the expression evaluate to null, then the function returns null. For more information about these functions and other functions available, see the Functions section in the Oracle Database SQL Language Reference for 12c. In this video, we've described the general functions used when working with data pertaining to null values in a SQL statement. In this video, we're going to learn how to use the NVL and NVL2 functions when working with null values in a SQL statement. To convert a null value to an actual value, use the NVL function. The syntax for the NVL function is NVL, open brackets, we pass expression 1, comma, expression 2, close brackets. Expression 1 is the source value or expression that may contain a null. Expression 2 is the target value for converting the null. You can use the NVL function with any data type, but the return value is always the same as the data type of expression 1. The data types must match. For example, if expression 1 is a number, then expression 2 must return a number. The example in the slide calculates the annual compensation for all employees by multiplying the monthly salary by 12 and then adding the commission percent to the result. Notice that the annual compensation is calculated for only those employees who earn a commission. If any column value in an expression is null, the result is null. To calculate values for all employees, you must convert the null value to a number before applying the arithmetic operator. In the example in the slide, the NVL function is used to convert nulls to 0. The NVL2 function examines the first expression. If the first expression is not null, the NVL2 function returns the second expression. If the first expression is null, the third expression is returned. In the syntax, it's NVL2, open brackets, expression 1, which is the source value or expression that may contain a null. Expression 2 is the value that is returned if expression 1 is not null. And expression 3, which is the value that is returned if expression 1 is null. In the example shown in the slide, the commission percent column is examined. If a value is detected, the text literal value of cell plus com is returned. If the commission percent column contains a null, the text literal value of cell is returned. Note, the argument expression 1 can be any data type, but expression 2 and expression 3 must be of the same data type. We are in Sql Developer, and we will demonstrate first the NVL function and then the NVL2 function. For the NVL function, our SQL statement will look as follows. We are going to select last name. We'll specify the NVL function. We're going to convert our commission column to a character. And if the function evaluates to null, we will return no commission. We give our column a heading. We're selecting from the employees table where last name is like capital H. We would like to see the commission column for all employees whose last name starts with a capital H. We execute our SQL statement. In the query result window, we can see all employees whose surnames start with a capital H and whether they receive a commission. If their commission is null, it returns no commission. Next, we're going to demonstrate the NVL2 function. For our NVL2 function, we're going to query the employees table. We will look at the manager ID column. If the employee has a manager, it will return the value manager. If the employee does not have a manager, it will return no manager. Our SQL statement will look as follows. We will select last name. We will specify our NVL2 function. We will once again convert our manager ID column to a character. We will then specify if the manager ID has a value, it will return manager. If the manager ID is null, it will return no manager. We'll give our column an alias called manager. We select from the employees table and we're going to order by employee ID. We execute our SQL statement. In the query result, we can see all our employees are returned. Where the employee does not have a manager, it has returned no manager. And for all the employees where there is a manager assigned, manager is returned. Now you know how to use the NVL and NVL2 functions when working with null values in a SQL statement. In this video, we're going to learn how to use the null-if and coalesce functions when working with null values in a SQL statement. The null-if function compares two expressions. The syntax for the null-if function: null-if, open brackets, expression 1, comma, expression 2, close brackets. In the syntax, null-if compares expression 1 and expression 2. If they are equal, the function returns a null. If they are not, the function returns expression 1. However, you cannot specify the literal null for expression 1. In the example shown in the slide, the length of the first name in the employees table is compared with the length of the last name in the employees table. When the length of the names are equal, a null value is displayed. When the length of the names are not equal, the length of the first name is displayed. The coalesce function returns the first non-null expression in the list. The syntax for the coalesce function: coalesce, open brackets, expression 1, comma, expression 2, comma, expression n, close bracket. In the syntax, expression 1 returns this expression if it is not null. Expression 2 returns this expression if the first expression is null and this expression is not null. Expression n returns this expression if the preceding expressions are null. Note that all expressions must be of the same data type. The advantage of the coalesce function over the NVL function is that the coalesce function can take multiple alternative values. In the example shown in the slide, for the employees who do not get any commission, your organization wants to give a salary increment of $2,000. And for employees who receive commission, the query should compute the new salary that is equal to the existing salary added to the commission amount. In the query output, for employees who do not get any commission, the new salary column shows the salary incremented by $2,000. And for employees who get commission, the new salary column shows the computed commission amount added to the salary. Now we will go to Sql Developer and we will demonstrate the coalesce and the null-if functions. To demonstrate the coalesce function, we are selecting from the product information table where the calculated value is null. In our SQL statement, our coalesce function, we are going to pass expression 1, which is a calculation on the list price column. For expression 2, we're going to pass the min price. And for expression n, we'll pass the value 5. Let's execute our SQL statement and review the output. In the query result, we can see for line 1, where the list price is not null, expression 1 is returned in the sale column. In line 2, we can see where the list price is null and the min price is not null, we return expression 2. And lastly, we can see for line 5, where the list price is null and the min price is null, we return expression n, which is the value 5. To demonstrate the null if function, we have a query in our Sql Developer session. Our null if function compares the job ID in the employees table with the job ID in the job history table. If the values match, a null will be returned. If the values do not match, the job ID for the employees table will be returned. Let's execute this SQL statement and review this output. In our query result, we can see for these employees, the values did not match, and therefore the job ID is returned from the employees table. For employee Taylor, the job IDs matched between the employees table and the job history table, and therefore a null is returned. The second entry for employee Taylor returns the value SA_rep. This is due to there being multiple rows for the employee Taylor in the job history table. Where the columns matched, a null was returned. Where the columns did not match, the job ID from the employees table is returned. And that is how we use the null if and coalesce functions when working with null values in a SQL statement. In this video, we will introduce conditional expressions, which are used to provide the if-then-else logic in a SQL statement. The methods that are used to implement conditional processing, in other words, the if-then-else logic in a SQL statement, are the case expression, the searched case expression, and the decode function. The case expression complies with the ANSI SQL standard. The decode function is specific to Oracle syntax. In a simple case expression, the Oracle database will search for the first when-then pair for which the expression is equal to the comparison expression and returns the return expression. If none of the pairs meet the condition, an else clause exists. In a searched case expression, Oracle searches from left to right until it finds an occurrence of the condition that is true, and then returns the return expression. If no condition is found to be true, an else clause exists. The decode function compares an expression to several search values. Whenever the value of the expression matches a search value, the decode function will return the result associated with the search value. If no match is found, it returns the default value. We have introduced the conditional expressions case, searched case, and decode. Please see the upcoming videos where these expressions are covered in more detail. Using the case and searched case expression to facilitate a conditional inquiry in a SQL statement. Case expressions allow you to use the if-then-else logic in SQL statements without having to invoke procedures. In a simple case expression, the Oracle server searches for the first when-then pair for which expression is equal to comparison expression, and then returns the return expression. If none of the when-then pairs meet this condition, and if an else clause exists, the Oracle server returns the else expression. Otherwise, the Oracle server returns a null. You cannot specify the literal null For all the return expressions, the expressions, expression, and comparison expression must be of the same data type. This can be a char, a varchar2, an nchar, an nvarchar2, a number, a binary float, or a binary double. Or they must all have a numeric data type. All of the return values must be of the same data type. In the Sql statement in the slide, the value of job ID is decoded. If job ID is IT_prog, the salary increase is 10%. If job ID is ST_clerk, the salary increase is 15%. And if job ID is SA_rep, the salary increase is 20%. For all other job roles, there is no salary increase. The same statement can be written using the decode function. Introducing now the searched case expression. In a searched case expression, the search occurs from left to right until an occurrence of the listed condition is found, and it then returns the return expression. If no condition is found to be true and if an else clause exists, the return expression in the else clause is returned. Otherwise, a null is returned. The searched case evaluates the conditions independently under each of the when options. The difference between the case expression and the searched case expression is that in a searched case expression, you specify a condition or predicate instead of a comparison expression after the when keyword. For both simple and searched case expressions, all of the return expressions must have the same data type: a char, varchar2, nchar, nvarchar2, number, binary float, or binary double, or must all have a numeric data type. The code in the slide is an example of a searched case expression. We are in our Sql Developer session, and we have two Sql statements in the Sql Worksheet window. The first Sql statement contains an example of a simple case expression. The case function displays the grade of all employees based on the job ID column. Where the job ID is not referenced in the case expression, a 0 will be returned. Let's execute this Sql statement and review the results. In the query result window, we can see a 0 is returned for the grade where the job ID was not referenced in the case expression. If we scroll down, we can see a grade is returned for each of the job IDs referenced in the case expression. Our second Sql statement contains an example of a searched case expression. Where the commission percent is within a range specified in the case expression, we return either junior, intermediate, or senior. Where it does not meet the search criteria, we return manager. If we execute this Sql statement, in our query result window, we can see where the employees receive less than 2% commission, their sales grade is returned as junior. Scrolling down, where it is less than 3%, their sales grade is intermediate, and so on. We have introduced you to the case and the searched case expression, and you are now ready to use these expressions in your Sql statements. Using the decode function to facilitate conditional inquiry in a Sql statement. The decode function decodes an expression in a way similar to the if-then-else logic that is used in various languages. The decode function decodes expression after comparing it to a search value. If the expression is the same as search, the result is returned. If the default value is omitted, a null value is returned where a search value does not match any of the result values. The decode function is specific to Oracle syntax, whereas the case expression complies with the ANSI SQL standard. The example in the slide tests the value of the job ID. If the job ID is IT_prog, the salary is increased by 10%. If job ID is ST Clerk, the salary is increased by 15%. If job ID is SA_rep, the salary increase is 20%. For all other job roles, there is no salary increase. The same statement can be expressed in pseudocode as an if-then-else statement. If job ID equals IT_prog, then salary equals salary times 1.10. If job ID equals ST Clerk, then salary equals salary times 1.15. If job ID equals SA_rep, then salary equals salary times 1.20, else salary equals salary. This slide shows another example of using the decode function. In this example, you determine the tax rate for each employee in Department 80 based on the monthly salary. Let's go to Sql Developer now, and I will demonstrate the output of this SQL statement. We are in Sql Developer. We have our SQL statement in our Sql Worksheet window, and I'm going to execute the statement. In the query result window, we can see employees who earn a salary between $6,000 and $7,999 have a tax rate of 30% applied. Scrolling down, employees that earn between $10,000 and $11,999 have a tax rate of 42% that is applied. Employees that earn over $4,000 have a tax rate of 45%. We will now look at another example of a decode function. In this example, we are selecting the job ID, and we're going to decode the job ID column to give each job ID a grade. Where the job ID is not listed, a 0 will be returned. Let's execute this SQL statement. In the query result, we can see where a job ID has been specified, so our AD_Pres, his grade is A, as decoded in the SQL statement. Scrolling down, we look at some more examples. The IT_prog job ID returns a grade C. We can see for the job IDs that were not decoded in our SQL statement, they return a grade 0. You are now ready to use your decode function to facilitate conditional inquiry in a SQL statement. Now that you've learned the basics of working with functions and conditional expressions in a SQL statement, it's time to put that knowledge to work. In this exercise, you will display each employee's last name, hire date, and salary review date, which is the first Monday after 6 months of service. Label the column Review and format the date to appear in the format Monday, the 31st of July, 2000. For the next task, you will create a query that displays the employee's last name and commission amounts. If an employee does not earn commission, show no commission. Label the column COM. For the last task, you will use the case function to write a query that displays the grade of all employees based on the value of the job ID column. Use the data in the table for your case function. When you are ready, pause this video and perform the exercise. When you are done, come back to the video and I will work through the exercise with you. We are logged into our HR connection in Sql Developer. In the first task, we need to write a query to display each employee's last name, hire date, and salary review date. The salary review date is the first Monday after 6 months of service, and the column will be labeled Review. In our select statement, we specify the last name column, we specify the hire date. To return the review date, we first use the add months function to move the date forward by 6 months. We then use the next day function to find the date of the following Monday. Lastly, we convert the entire function to a character string. This is so that we can return our date in a sentence. Let's execute our statement and review the output. In the query result, we display the employee's last name, their hire date, and the review date. The review date is the first Monday after 6 months of service. For our next task, we will create a query that displays the employee's last name and their commission amounts. If the employee does not receive a commission, we will display the words "No Commission." We will label the column COM. In our select statement, we select the last name. For the commission column, we first use the toChar function to convert our commission % column to a character data type. We then use the NVL function to return the words "No Commission" should the column contain a null. Let's execute this statement and review the output. In the query result, we return the last name for the employee. Where the employee's commission % column is null, we return the words "No Commission." If we scroll down, we can then see for the employees that do receive a commission, their commission percentage is returned. For the last task in this exercise, we'll write a query to display the grade of all employees based on the value of the job ID column, using the data displayed in the slide. Our SQL statement, we've included the last name for the employee, their job ID, and we've then specified a case function where the job ID is equal to st_clerk, return an E. This we do for each of the identified job IDs. If the job ID is not specified, return a 0. Let's execute this statement. In the query result, we return the last name, the job ID. Where the grade was not specified in our case function, we return a 0. And for each grade that was specified, we return the relevant corresponding value.